Nu tā, labdien visiem! Ja jūs mani lēnām sākat dzirdēt, tad jums ir viss kārtībā.
Hello, good morning, ladies and gentlemen. If you hear me, then it means that everything is as it should be with the sound. However, if you don't hear me, then you need to adjust the sound on your computer or other device. If you use Zoom on your computers, then you can also use interpretation.
Just checking if you don't listen to interpreter's speech, then you might be on Latvian channel, which means technically you should click to another channel in this Zoom options. And there are options in English, so for those who do not command fully Latvian. But anyway, you can make a choice. You can learn Latvian as well. Not only a great subject of nuclear energy, so how to introduce this in Latvia. Maybe it is even inventable. So anyway, I'm switching back to Latvian. Tātad, kā jūs saprotat, es šai mirklī vienkārši teicu labdien.
As you understand, I simply informed everybody that interpreting is available. This is an international conference, so everybody can choose either to listen to the original speech or listen to interpreting in Latvian or English. We will talk today about various scientific inventions, and we will have highly honorable lecturers and speakers among us. There will be different people from different scientific fields who will talk about myths and beliefs regarding nuclear energy. Nuclear energy is quite famous, or want to say infamous. Somebody say it is not the greenest or the cheapest solution at the moment. It is all the time standing on crossroads. 20 years ago, I, as a journalist, was in Brussels and I filmed a news report on solar energy, and somebody said it is not something that could be deployed while we are alive. It could simply probably be deployed or introduced in within 200 years of time. But nowadays we widely use solar energy, and probably also nuclear energy could be introduced and deployed with no time. I would like to thank all the organizers who have developed such an interesting agenda. They not only have chosen very exciting and interesting presentations, but they have also made calculations. And according to the calculations, around 7 million gigawatts are necessary for Latvia to meet all our energy consumption. Most likely, we will use electricity for many things also in the future, and this conference is happening thanks to electricity. Power supply company Latvenergo is also among our supporters and sponsors as well as hosts of this conference. But there are many interesting conversations and discussions planned for this conference. If you use Zoom application, you can also ask us questions. You can ask them in chat section of Zoom. Write also the address, which speaker should answer your question. Probably if discussions are very heated and it takes a lot of time, then we won't be able to follow the chat section, but we will try to answer all the questions as much as possible. Some of you have connected to the conference in Delphi. It is an internet portal, and it is also related to different data protection issues. But we will talk a lot about data, so please follow the data information we tell. This will be the first attempt of explaining the role and meaning of the nuclear energy to broader society. Latvia is also considering nuclear energy as a potential solution for future. Our Ministry for Economics is in quite an unstable position. We don't know whether he will be minister in the upcoming months or not, but he has recorded his speech, and please listen to him. He is also our Ministry for Energy. Ladies and gentlemen, dear participants of the conference dedicated to nuclear energy, I would like to thank you for participating in this format in today's conference. This is an unprecedented event in the field of nuclear energy in Latvia. I would say it is still in baby steps here. There have been different speculations or opinions on the usefulness and necessity of this source of energy and its usability in the future. But we haven't had in-depth expert analysis and discussions yet. I am positive regarding this source of energy. We have had also a national agreement with First Dynasty in the US. I don't think that capacity of other renewable sources of energy like wind or solar energy could be increased significantly in the future. These sources of energy are quite unstable and they need to be balanced. There are different visions regarding what is considered a modern contemporary power plant to meet our modern needs. At the moment, all the discussions are still theoretical, but the things you are doing at the moment, that you have organized this conference and you are ready and willing to discuss the role and national position of the nuclear energy, then great things are ahead of us. We could involve our scientists and technical minds, and this is simply the first initial signal. This is a signal to make us all go in the right direction. And if we are lucky and if all things happen the way they should, and it is economically feasible, then we should definitely move towards nuclear energy.
Šo attieksmi, tas galu galā visdrīzāk nemainīsies, pat ja mums pēkšņi mainās valdības sastāvs tuvākajā laikā, problēma paliks.
I would like to thank the Minister for his address. Most likely the situation in energy field in Latvia won't change in the upcoming future so dramatically. We should use our scientific potential and look for different ideas how to solve our energy issues and ensure energy security in the future. There have been more than 300 participants who have applied for this conference, and one of our partners and sponsors is Fermi Energia. That is one of the agents. It is one of the agencies that bases its operations on detailed scientific calculations and perspectives. Also, different scientific institutes and their representatives have joined this event. Among the participants, there are also several NGOs, General Atomic, World Atomic Association, International Movement, Stand Up for Nuclear, and University of Latvia Institute for Solid State Physics. These are just some of our participants. All of us together will be held by the training Center for Development Innovations. That is a foundation that tries to tackle different myths and misbeliefs related to nuclear energy. This organization is aimed at public awareness raising. And one of the people that could be in the best position to clarify different myths and misbeliefs is Vice President of Latvian Academy of Sciences and also the laureate of the Grand Medal of the Scientific Academy, Mr. Māris Šternbergs. I would like to give the floor to Andris Šternbergs, but before that, I would like to give the floor to Mr. Minister of Defense, Artis Pabriks. I thought it's enough with one minister, but now we have a recorded speech of another minister. It is Minister of Defense. Nuclear energy is also an issue of defense. If you have food security and if state has new energy security, it's a welfare state.
Dear attendees, according to the analysis by experts, there are 3 types of resources in the world that are very important. We can't go on without them, and we are fighting over them. That is food. We see it now with the Russian attack on Ukraine. That is water, which we have a lot of in Latvia, and that is, of course, energy. In the case of Latvia, energy or acquisition of energy is one of the most critical questions. Even if we have a lot of food and water, we're not so lucky with energy. If we take a look at natural resources, here's how our future looks like. Firstly, this energy is not sufficient for us. We need heating, we need industry, we need manufacturing, and it all must be clean and so that we do not pollute the environment. We must leave Russian gas behind. We cannot rely on a neighbor where the economy is subordinate to different political, geopolitical, or imperial ambitions. So what are we left with? We are left with our hydropower. We have, of course, our forests that we can produce wood chips and pellets and use them both for heat and heating. We are left with modern green energy, which is used more and more in European countries and all over the world. Of course, that's wind and solar, but that is not sufficient in my opinion. And here, I think we should return to using nuclear energy in the Baltic region, but on a new scale and in a modern way. If we want to be modern, developed, clean, and if we want for this energy, heat, and electricity to be provided independently, regardless of sufficient wind or sunshine, I don't see any reasonable alternative other than nuclear energy. And in my opinion, given the fact that we're not a large power, it would be best to do so along with one of our neighbors. I believe that there's a similar type of modern thinking in our neighboring country of Estonia. I know that among our partners in Sweden or Canada or elsewhere, we can find many economical business offers which would help us create a mutual agreement on the modern and safe use of nuclear energy for the needs of our economy or society and in a way that is ecologically clean. From this perspective, I will definitely be one of the politicians that will support this development in our energy policy, and I hope that among the listeners there are both thinkers and doers who could work together in order to move us ahead, so that we here in Latvia would have not only a lot of water, not only a lot of food, but a lot of green energy, which wouldn't make us dependent on other countries, especially unfriendly ones. Thank you very much. Yet in the situation of war, if it makes things more unclear, remember there was this statement about Chernobyl and Zaporizhia, the nuclear reactors. Everybody in the world had their hearts beating faster. So you should definitely take these into account in your lecture. Today we talked about Russia saying that Finland doesn't want to pay for natural gas in rubles. And of course, Finland has applied for NATO. So this energetic pressure might be a part that interests us. Russia was one of them, the ones that said that Finland, oh, why are you building nuclear reactors? Of course, all of these questions, you should definitely present them to us, put them on the map. And don't remember, of course, the Latvian national interests are above all, and we're putting the central stones for our buildings. Yesterday on TV, I saw some information on Zaporizhia, and So there will definitely be some allusions to that. So our prism of our national interests here. So thank you very much. Thank you, Ansi, for the introduction on the Institute and all the ministers who gave a great introduction to this lecture. And this political support makes it much easier to speak. But of course, we will be talking from a point of view of science. As you can see, I've added two linked themes. So energy challenges during the energy crisis and critical climate change, and green. And the second point is green nuclear energy as a long-term solution for baseload capacity. And that applies especially well for Latvia. And on the top, I've added that a lot has to do with the work of scientists to develop the understanding of where we're going, how we're improving the sources of energy. And we'll be talking about alternative resources. We should remember that the environment is very important as well. And my main thesis is that green energy is one of the long-term solutions. Did the slide change? Yes, it did. So maybe I will start with, since I'm a physicist, I'll start with the Nobel Prize in Physics in 2021, which was obtained by these scientists, which were linked to climate change. And they showed that one of the main topics in climate change is how to lower carbon dioxide emissions, which is very important, which is something we should work on together. So that was one of the main questions in the Glasgow conference. So it's quite slow here, the presentation. Okay, so that's what I just mentioned. So again, the slides are going very slowly. Okay, so on the Glasgow conference, one of the main goals was to say that we must understand that in the coming years, till 2030, we must lower the temperature changes. They should be lower than 1.5 degrees per decade. And in the bottom, I've added that one of the goals that should be kept in parallel is the transition to a zero carbon or low carbon economy in technologies and manufacturing and everywhere else. This was already talked about, alluded to by Pabriks, the Minister of Defense. So on achieving a sustainable energy future, first of all, it's solar cells and solar generators, solar wind generators. And lastly, we started to understand that hydrogen energy can be collected with hydrogen as well. So there are projects developed in Latvia which combine wind generators and H2 fuel cells. And we must remember that Latvia has a huge advantage now that we use the Daugava River and we use hydroelectric plants. And there's a status we've obtained as one of the top users of hydro energy. And lastly, of course, a vision of the future. Perhaps we might collect dark energy in the future. Moving on, I wanted to talk about what are the main things in energy. It is storage as well, not only acquisition of energy. So here we talk about lithium batteries, but other batteries as well. For example, so lithium is quite catastrophic for the environment. Of course, there are supercapacitors as well. And as I said, hydrogen can be used for storage as well, a storage of energy. And another thing, the economy is concerned with how we best use the energy and using it the least amount possible. So all electric appliances are going for lower electricity consumption, for example, LEDs and OLEDs as well. We do not use standard old light bulbs. And of course, energy efficient housing is important as well. For example, smart windows, which control the entering and exit of energy with thermochromic effects. And another thing, we see fossil fuels here. The minister already referred to them. So we should find a way we could replace the fossil energy sources. So it should be go hand in hand with replacing them with green sources. So one of the sources, of course, can be nuclear energy. And this is just a general slide where I just want to stress something I already said, that 2/3 of all the energy supply will be gained from green sources by 2050. But to compensate for the loss of power with fossil fuels exiting the picture, we must double the amount of nuclear energy we receive. Of course, just short equations, two types of obtaining nuclear energy. So nuclear fission is the first one, and the second one is the future. I'll be talking about it a bit less. So it will be nuclear fusion, which is something that happens on the sun. And the sun is essentially at the top of all our energy sources. For example, wind, fossil fuels, as I tell my students as well. And without the sun, we cannot exist. And nature cannot exist without the sun. So that's why we should cooperate, so to say, with nature and the environment. We shouldn't attack it too much and destroy it too much. With the renewable resources, sometimes there can actually be damage to the environment. It's a really old slide I have here. It says that if there is a future, it will be green, said by Petra Kelly from Germany. So let's not go into too many details about the picture as well. Of course, at the basis of everything, the fundamentals of this question is radioactivity research, and of course, Albert Einstein. This is the first recording, so to say, of E = mc². So it says that mass and energy are one and the same physical units and can be transformed into each other. So if I refer to fission, if we perform fission, we lower the mass. But in fusion, we heighten it. So, but in either way, it results in a huge explosion of energy. I won't be talking too much about this cycle, but it's the fission cycle. Of course, we can talk about it in a more scientific context in a different conference, how uranium is used and how it goes through the cycle. And so uranium, enriched uranium is split, and it splits when it reaches its critical mass, and that produces neutrons, which form a chain reaction, and the process continues. And it's clear that afterwards, an element is heated up. For example, steel is heated up, and that results into steam. And of course, that's the way the nuclear reactor works. In short, of course, they're all thermic energy sources, which is transformed into electricity. So this is the general principle of how the nuclear power plant works. Of course, there can be different types of power plants. of nuclear power plants, but the end principle is one and the same. It's so, for example, there are different types of reactors, for example, pressurized water reactors. There are different tricks and types that you can heighten efficiency of these reactors. So, like I said, the main types of power plants. So the pressurized water reactor, boiling water reactor. One of the simplest ones is the boiling water reactor, which actually will be used in Estonia, which is similar to a Canadian reactor. And like I mentioned, the heavy water reactor. And there's a fast breeder reactor where the fuel is put into the next cycle and the uranium is used much more efficiently. And again, I believe it's stated here that the nuclear power plants, they are a thermal power station in which the heat source is a nuclear reactor and then it's transformed into electricity. I think I already mentioned that previously. So a bit of statistics here on renewable energy sources. So the leader of renewable energy sources are the soon-to-be NATO members, Sweden and Finland. Oh, I'm sorry. Yeah, Sweden is a bit lower, but Latvia is in the red. Marked in red. Oh, and we see that we are quite good at using our renewable energy sources. Estonia and Lithuania are quite high up as well, our neighbors. But as we remember, they received a lot of electricity from the Visagina power plant in Lithuania. And on the table next to the first one, how the EU 27 countries get their electricity. So in the EU, we see that the nuclear energy sector is quite large even now. Then we have gas, wind, hydropower. Then we have lignite, coal. I've added them in black. So these are the classic three of fossil fuels. Then we have bioenergy, solar energy. Solar energy is quite low on this ranking, although Germany is putting high hopes on solar energy and wind as well. And lastly, we have other fossil sources at the bottom. And next, which are the countries with the largest nuclear power generation? So these are the countries that get the most of their nuclear power generated from power plants. So, of course, number one is the USA. Then we have France. So you can see that they're leaders in Europe. Then we have China, Japan, Russia, South Korea, and even Ukraine. Although the number seems quite low because Ukraine has large nuclear power plants, for example, in Zaporizhia. And then we have Great Britain and Sweden. And on the largest reactors in the world, the largest one is, as it turns out, so it's a boiling water reactor. It produces a power of almost 8,000 megawatts, so it's Kasiwazaki Kariwa. Then we have the Canadian Bruce plant. Then we have South Korea's Hanul. And lastly, the largest one in Europe is the one I already mentioned. It's Zaporizhia. So this game from the Russian side was quite unpleasant. So in case they actually did something to Zaporizhia, it's close to the Russian border. So that would be borderline suicide for Russians themselves if they actually damaged the plant. So I guess common sense sometimes does gain the upper hand in Russia. So the principle about fusion, nuclear fusion, which is, of course, an affair for the future. As Andris, the moderator, mentioned already, that he talked about his children maybe experiencing this in the future. Of course, there were expectations that it might happen around 2050. But now, moving the ITER in France, in Cadarache, not far from Marseille. So now we see that we still have a far way ahead of us. But one thing should be said, that nuclear synthesis and its opportunities of generating power is so fusion has a much higher capacity of producing power than fission. Of course, there are some calculations still to be made, but then again, I must remind you that the sun works on the same principle, and the sun is quite smart. So, of course, we can see the track record that we have some good achievements. For example, in the UK, we saw that there was attempted fusion, which was actually held for quite a long time. So there were some issues with overheating, but for the ITER plant, there will be semiconductors and superconductor magnets with coils. So it's no surprise that actually China has already attempted this and has held the energy level for 17 minutes. I didn't know the whole yield they got, but that's it. So of course in Latvia we work with fusion as well, me included. Of course, lastly, I would like to touch upon low power modular nuclear reactors. I won't go into details because I will have colleagues who will talk about that. The small low power reactor is actually something that's used, has been used for a long time, for example, in submarines, as the defense minister already said. But of course, I'm reaching my conclusion. Of course, it's a scientific problem. Of course, both the energy crisis and the climate change. So these are crises that science has to deal with. So the role of nuclear reactors is growing, and we are awaiting great results from nuclear fusion in the future. So what's important is that nuclear reactors can work anywhere, in any weather, in any geographical locations, and they can work non-stop, and it is not linked to any disruptions. For example, that might be the case for solar and wind energy. Of course, scientific research and scientific experience must grow both in Latvia and Estonia, even starting with small reactors. Thank you very much.
Thank you, dear speaker. I already have several questions, and I saw that several participants have asked their questions in chat section of Zoom. Those of you who have managed to join this conference timely can also use the opportunity to ask questions in the chat section. So the first question, or rather a suggestion, okay, fusion and fusion reactors, so will take some time to be deployed. But we somehow have been led to believe that we will be able to cover all our energy consumption only with green energy without using fossil fuels. Would it be possible, or is it just a misleading argument? Well, this is also a political and economic problem or issue. Russia will definitely stand up for maintaining the use of fossil fuels. Also, US says that it has enough of fossil fuel reserves for at least a century. This is quite a complicated problem, and it has to be reviewed in context. European green agenda is both working in our benefit and at the same time causing us disadvantages. It is not only about energy consumption and energy security. We also need to think about health, environment, and energy security. Well, in China, you told about 17 minutes as a record breaking, as breaking the record for keeping the energy. Is it possible to collect this energy? At the moment, we don't have similar or equivalent technology in Europe or US. But if we manage to build a reactor that could be able to generate such an amount of energy that it not only covers our consumption needs, but also the surplus of energy generation. Would it be possible to collect this energy? What is needed for that also? Is it a political decision and agreement? It is about agreement among countries? Well, low power modular reactors won't be able to generate such an amount of energy that we need to think about collection. Low power modular reactors can produce such an amount of energy to meet all of our energy consumption demands, or at least part of that. It is not about accumulation. In China, rather, this experiment was used to push the boundaries and to demonstrate what a reactor is capable of. There are also prototypes of other similar reactors being built, but at the moment we cannot talk about surplus of energy production. There's a trend to move toward low power modular reactors. These reactors won't be able to generate like a surplus of energy balance. ITER reactor in France will only have around 800 megawatts. Well, at least this is what is intended or expected for the demo version of ITER reactor. But this only applies to the demo version of the ITER reactor, and what knows what is to be expected in the future. Well, thank you very much for the presentation. I also see that somebody have written their opinion in the chat section, and discussions always form a basis for scientific inventions and discoveries. But now I would like to give the floor to the next speaker, who is Kallemets, who is co-founder and CEO of Fermi Energia.
For Latvians, and I heard it's the same for Estonians, sometimes when you say that, well, there is, one step ahead in Estonia introduced or at least decided, then Latvians go even more faster. So tell me, this might be a nice reason. Oh, jums vēl nav mikrofons. Ne, ir microphones. No, we were talking about the microphone if you have it. So my question is, how far you made steps one single country, because we always had this feeling that on the terms of energy, and especially nuclear energy, we might do a common decision. So if you are here with a proposal to form a kind of Baltic initiative, And I think we should consider Finland as well in the same family, and maybe even Poland. Or do you think each and other country should do it on their own political decisions? And of course, the most interesting part is how this micro generation of nuclear works. So please.
Laba diena.
Laba.
Hello, friends from Latvia. I'm from Fermi Energia, and I'm gonna explain what we do in Estonia, and then you are able to make your own decisions. First off, 103 years ago, in June, Estonians and Latvians together, we won a battle of chesses against the Germans to free our countries and avenge for occupation for many centuries. And then we together fought the Russians. So there are not too many who have done that, fought against the Germans and the Russians at the same time and won. So we have had good experience of cooperation. And today we have to decarbonize and we have to get energy independence seriously. And there is room for cooperation as well. A little bit about Fermi Energia. It was unfortunate that our Lithuanian friends did not manage their nuclear deployment project very well, and it was not successful for internal political reasons. But the positive thing that Estonians took from that was that several young people were sent to study in Stockholm, and they finished with PhDs. And with those people, we decided in 2018 to form a new company, Fermi Energia, because we saw that the small modular reactors, they were seriously in licensing, and they were seriously in development in Canada and United States. And we knew that the decarbonization has to happen. We knew that there has to be dispatchable power in the Baltic states. And we knew that the old fossil plants, they will not be around forever. And, but we did not know that the CO2 price will be 85. We did not know that Russia will start a war against Ukraine, and Europe will decide to not terminate the energy dependence from Russia. Since then, 2019, when we founded, we have built our team through continuous work, and we have concluded several studies, total of 60 studies. We have 1,300 shareholders, mostly Estonians, but also Vattenfall from Sweden, and we have a good partnerships with Fortum, Hitachi, Rolls-Royce. I'm gonna explain what we have done and what is the logic behind SMR deployment development in Estonia. So in the Baltic states, we are in a significant dispatchable power deficit in winter season especially. This is hourly basis last year from 1st January to 1st June, showing the deficit, especially in the heating season. It is consistently 2,000 megawatts, which we are covering now with imports and fossil fuels. And this situation will get worse as a lot of dispatchable power capacity in North Europe will be closed. And we see the effects of that already. So this was last week. Today the prices are almost the same. They are close to 200 euros for Estonian, Latvian and Lithuanian power consumers. And now the new situation is that Russia has stopped power exports to Finland because they are not very happy that the Finns have decided finally to join NATO. And unfortunately, a lot of coal capacity will be closed in the North Europe. This will mean, objectively, that the prices will be more expensive. And we look at the power generation in Germany in October. Wind is not blowing every day. Sun is not shining in the autumn. This cannot be changed with any hope or planning or whatever. The wind just doesn't blow and you have a problem. So dispatchable capacity is absolutely needed. Our aim is to achieve stable priced power output with long-term power purchasing agreements to industrial customers in Estonia, but also in Latvia and Lithuania. Because we know that industries, but also public institutions, like universities, like ministries, like defense, they need stable power prices to plan their budget, to plan their investments, because all the production units, they consume electricity. So large nuclear really is large. Olkiluoto will be finished in Finland, but small modular is smaller than large nuclear and makes a huge difference in construction time, in construction risk. Service life is the same, but the cost of electricity is likely lower because the construction time is lower and the interest during construction is lower. The building volume is smaller, the complexity is smaller. And we have smaller power grid systems, so small is suitable for Estonia, Latvia, and Lithuania. Large actually is not. So we have looked at many designs, and this is the reference design, Pabriks 300 by GE Hitachi, and that has been chosen for deployment by the Canadian largest utility, Ontario Power Generation. License application will be submitted September of this year. Also, large American utility, Tennessee Valley Authority, has chosen this technology. Also, Poland, Synthos Green Energy, has chosen this technology for 20-unit deployments. This is the most common reactor technology operational in Finland and Sweden. It is well known by academia, regulators, and the utilities. But also pressurized water system, which is operating in Loviisa, but also in Ringhalls. It is very well-known technology. Majority of the world nuclear reactors are pressurized water reactors. So this Rolls-Royce technology that is well-funded by the government of United Kingdom, but also private sector, is quite credible design. So these are the two designs between which we are going to choose next year. In Estonia, indeed, there have been official decisions made. Last year, the government formed Nuclear Energy Working Group, which will submit by September of this year intermediate report, and the government mandated in April of this year that the final report of this working group would be submitted by end of next year. After this, the Estonian Parliament can make a knowledgeable commitment on nuclear energy program, based on which the nuclear energy law can be adopted, and the nuclear energy regulator can be formulated out of Radiation Defense Department of Environmental Board and Technical Safety Regulator, which regulates existing power generation, fossil power generation in Estonia. And at the same time, to have a speedy deployment, we need to perform also the planning procedure, essentially citing environmental impact assessment. So to conclude that by 2027, that we could submit the application for the construction license. We ourselves, the Fermi Energia, we have to do a lot of work to develop a lot of capabilities. And in 2025, we understand we need to form the consortium agreement, secure the land to prepare really the construction license application, which is very substantial technical document, which includes obviously also the safety assessment review in 21 chapters. And we have listed all those chapters. We know who's going to be responsible for each chapter in the organization, and we will hire additional staff for executing those challenges. And then we are able to go through the licensing based on UK or Canadian license, and to start hopefully construction 2028, to have reliably power generation after startup procedures and receiving the operator license by 2031, because we need power, reliable power supply as quickly as possible. This year we had a normal winter. Next year we might have a colder winter. And if we have a colder winter, the prices will be even higher than 400, 500, 600 euros per day. So we need energy for transportation, heating, lighting, for our industries. And so energy is the heart of our economies, is the heart of modern societies. To make knowledgeable decisions, you need knowledge. Knowledge you can gain by studying, and you get confirmed when you have concluded with your studies with a degree, be it a bachelor, master's, or PhD, or you conclude by commercial, serious studies based on which you can make decisions. So we recently have concluded 7 different studies, and we are very happy to cooperate with Latvenergo, with whom we have an outstanding MOU from October of last year, and a good study on the market impact of SMR deployment on Baltic power market. We're really pleased on the professionalism of Latvenergo team and also the results that they demonstrate. We performed also financial strategy for 600 megawatt SMR deployment with Vattenfall AB, and they also showed solid results when we are securing significant part of the power generation with long-term power purchasing agreements. And so we have studied macroeconomic impact for Estonia. We have studied supply chain from Estonian companies that are producing already components for power engineering. We have ABB, for example, in Estonia, Prysmian that produces cables. We have Arjo, Estonian capital company that has mid and low voltage equipment, distribution systems. And we have studied, of course, the safety of these different designs. We're going to study the safety of Rolls-Royce design later this year. And we have in-depth studied the deployment program, done risk analysis with professionals from Finland. So always the question is, what is the public going to say? So here is in Estonian language, we have evidence that we have measured every 6 months the public support for consideration of small modular reactor to ensure security of supply in Estonia. And when we started, the support level already then was more than 50%. And we were quite surprised by that result. But now, in January 2022, the support level has reached 68%. And we have to remember that when Estonia joined European Union 2004, then we had a referenda, and then the public support for EU was 66%. So having some support level close to that is almost as high as is possible in democratic societies. And we definitely want to keep and need to keep democratic societies where is diverse opinions. And nuclear obviously brings up diverse opinions, like it is the same case with taxation, like it is the case with vaccines or masks, or with any other issue in the society. There are always different kind of opinions, but everybody needs power. So even though we will never ever have the support level of North Korea or even Russia supporting the supreme leader of the nation or something like that, the support level of 2/3 of the society is really sufficient to proceed with decision making for politicians. And we are very pleased that in Estonia, different parties recognized the need for dispatchable power generation, also recognized the need for decarbonization. Because let's face it, the fossil energies that we have been using for 100 years, and we have burning millions of tons of oil shale every year, this has consequences. Right now, we have a massive heat wave for hundreds of millions of people in Pakistan and India. Hundreds of millions of people are experiencing for weeks 50 degrees Celsius. And that is the reason why India has banned export of wheat. The wheat prices have gone very much up due to the war, but also due to the climate change. So the climate change will mean higher prices, disruption in the food supply, disruption in the precipitation patterns. It will probably, very likely mean forest fires in Latvia, Estonia, Poland. In Russia, we see massive forest fires already this spring. So we cannot neglect our responsibility, our job that we have to do with decarbonization. We cannot deny the responsibility that we have to stop burning diesel fuel, gasoline fuel in transportation. We have to switch to electrical vehicles. We have to stop burning natural gas in our cities for district heating. We have to decarbonize it. And nuclear can be an excellent solution also for district heat. In Tallinn, I know, because of the biomass and gas prices, the district heat prices are more than 70 euros per megawatt hour. If we are able to generate power, electricity, at 55 euros per megawatt hour, because thermal efficiency of steam turbine translated back, it means that the heat output cost is somewhere around 20 euros. So 20 is definitely less than 70 euros. And this matters also for district heat consumers in Riga. And many thousands of people are paying more because we are using fossil fuels. And in long term, fossil fuels will be more expensive. The CO2 price will be even more expensive than it is today. So yes, nuclear will definitely be part of the solution for the Nordic countries, like it has been in Sweden, Finland, Canada, UK. We too are Nordic nations, and we need to seriously study, learn, and most likely deploy that technology in a manner that is suitable to 21st century. And it's a great opportunity for Estonia, and I think it's a great opportunity for cooperation between Estonia and Latvia, and great opportunity for Estonia and Latvia to cooperate with our security allies, United States, Canada, and our Nordic partners who are joining now NATO. So thank you very much.
So thank you very much. Political will, how important substance it is to get it through. Because honestly, when you see a measurement of green energy already used in Latvia, and green energy that kind of covers all the needs in Estonia, you should work harder. So it might make, let's say, better understanding of politicians to do these super supports for Estonians than we would expect it from Latvia. Don't you have this feeling? I'm a journalist. I'm kind of trying to push sometimes because of the green substance in the statistics of Latvia is much greener than in Estonia. So you have better support in your country.
It's very difficult to make Daugava bigger.
No, yeah, well, we can try.
To get more water into Daugava. So expanding that is so what you need to do in Latvia, you need to not use diesel fuel anymore, not burn natural gas anymore. So this has to happen. And how to make it happen? You have to have much more electricity. And how do you generate that electricity? Yes, you can do wind, but wind doesn't blow all the time. Yes, you can have solar, but sun doesn't shine most of the year. So that is the challenge that we have.
Of course, and the challenges you just mentioned, actually to put these in proportions, the solid nuclear and all the rest of the greens will be probably answered by a next speaker, Māris. Māris is sorry, I switched to Latvian now. Māris Balodis.
Thank you.
Paldies, thank you very much.
Thank you very much. Māris Balodis is the Research and Development Director at Latvenergo and Master of Economics. And he will be talking on the behalf of a company that we hope will make solid decisions and make solid studies. So this nuclear generation principle will be crucial for Latvenergo. And regarding the investment Latvenergo has made, I've heard that you've invested a lot in the Baltic markets in the so-called solar parks. So, Māris, I'll give you the floor. Hello, thank you for giving me the floor. Of course, we invest in many fields. For example, making the existing plants more effective, and in the development of wind and solar farms as well. For the near future, we must think about how we could integrate other ways of manufacturing in our generation portfolio. And to understand that, we must understand why do we need it. In this graph on the right side, you can see where Latvia is located in these two axes. For the first axis is electricity consumption per capita, and the other one is GDP. And here we can see that there's a synergy between these two. So the higher the GDP, the higher consumption of electricity per capita. And even if we're in this mid-low level with electricity consumption, we have lower consumption than the European average. If in the future we want to gain our closest neighbors' levels, for example, Finland, Norway, or even Canada, in 20 to 30 years, we would have to work quite hard in the field of generation to ensure adequate generation. And the growth of a country is not only characterized by generation of electricity, but consumption of electricity in industry, which gives added value. Modern society not always understands the different means of producing electricity. You can gain electricity by changing energy. You cannot make energy, right? There are different types, and it's quite important to know how to do it in the most rational way. So here you have to take into account the available resources for the country, infrastructure, and the environment, which is the most important. In Latvia, hydropower will be very important in Latvia, and natural gas, unfortunately, will be still important until we find a replacement for that. Of course, there's still diversification of natural gas delivery systems going on, and of course, green hydrogen as well. So, like I mentioned, environmental characteristics are quite important. Like we said, with the example with Ukraine, there was a 100 megawatt solar park created, and it was good because the environmental considerations were there. It was the largest park in the world. Globally, we know that for more than 50 years, pipelines have been developed. So those are huge investments for many, many years. In order to push forward a huge project, you need decades. The biggest projects were carried out in the 60s, for example, Druzhba oil pipeline and the Colonial pipeline in the US. And of course, the development has been ongoing and industry is huge. And of course, we understand that if we want to change something in the supply chain in the short term, it is very complicated and problematic. And we can see that in the situation nowadays, in making fast decisions and actions. And of course, we think of different resources. To move to a nuclear power, we made this comparison. Each country finds it quite important to have strategic reserves to ensure safety of energy. So we can see the U.S. strategic reserves of oil, which is 649 million barrels of oils, which is around 1 petawatt hours of energy. So if we make a comparison, if we compare it to uranium, it would be 1,700 Westinghouse. So you need lots of resources to store oil in your country, reservoirs, and you need a lot of safety precautions in this case. So, but if we change it to the Westinghouse cassettes, you can fit all of them in just one train. For uranium, the highest producers are Kazakhstan, Australia, Namibia, and Canada. So these are not high-risk countries, so there's an opportunity of diversification in supply, and that gives an opportunity so if we need a different supplier of electricity, for example, for production of fuel, there are options. Ukraine is another option so they use Westinghouse cassettes, and they were supplied by Russia. So if you make the according certification, you can definitely use them. So in the 50 years of the apologies, if we make a comparison with Latvia, 7 terawatt hours per year, you would only need 35 such uranium Westinghouse cassettes. On a regional level, in the Baltics, we know some plans for each country, how they will develop up until 2030. You can see all 3 countries, Estonia included. There is no nuclear here because it's 2030. And we can see that export is maintained in the same level. It's quite significant, 23% as the median in Latvia. And then we see generation. It is quite volatile, and there should definitely be steps taken for storage of electricity, or you should make it stable and be able to dispatch it, So the Baltic region, after desynchronization with Brel, so Belarus, Russia, we've connected to some lines in Europe with Poland. This would be the only region in the world with so many direct current connections with synergy of renewable resources makes the managing of the system quite complex. So this is one of the reasons why there are risks of safety on different planes. So different actions are being taken. For example, synchronous compensators will be added. So these are rotating reserves, which ensure the stability of the system. And the same could be done by generators, for example, nuclear reactors, which would ensure the stability of the system in the future. And making a further description, we can see a graph on the left side for DC with inverters. You get a sine wave, which is necessary for for the grid. So here we have another graph for the potential future system if we had only low power reactors. And lastly, we have solar and wind energy. So with the automatic control of DC, which has, of course, an influence on the safety, which again makes the situation a bit more complicated. So everything, the generation should be dispatchable and easily manageable. We have a little table on the right side. We have gas, coal, hydro, nuclear energy. So we have information on their coefficient of power, and nuclear, of course, would have the highest coefficient of the use of power. Of course, there are costs involved, rather high costs. So no significant changes are used during the lifetime of nuclear reaction. Of course, it is a non-carbon technology, so it's dispatchable as well. So the transmission system operator has indicated the adequacy of power up until 2030. And this is a study regarding the three operators of the Baltic states. And they concluded that in 2030, the adequacy of power could be 45 to 105%. So there might be periods where there is not sufficient power. And then we would have to depend on deliveries from other neighboring countries. And what else is important is that in the demand for 2030, wind power is only 48 to 84 megawatts hours. So that shows how much we can depend on wind power in peak energy demand. In our modern society, in a large part of society, exact sciences are becoming less and less popular and interesting. And our choice in different surveys are not linked to well-known facts, and education is based. It's not really based in facts. So here we have an example on Latvian society, on the chosen means of production of energy, which would be the most supported. The number 1 and 2 are solar and wind. Of course, each individual should understand the facts about dispatchability and stocking of the energy. A lot of people do not take that into account, so that's why such answers and results should be taken with a grain of salt and interpreted. Of course, there is news that we need to work with society, individuals, in hand with the academic sector, and developing the knowledge in our society. And in order to move to sustainable energy in the future, we must understand that the most correct solution would be a balanced energy portfolio. And here we have an example from a reactor in Sweden, station in Sweden, where there is nuclear power included as well. So the green splash is not an explosion, it's just green energy. But the red sector is the nuclear energy, as we can clearly see how stable and how the energy production is and how it changes over time. So we can see that it's quite easy to ensure the necessary amount of power, an adequate amount of power when it is necessary. What else is important is emissions, and nuclear has the lowest amount of emissions together with hydro and wind. Of course, I should add here that biomass stations say that they have little emissions because, for example, wood would create these emissions just decomposing somewhere else. But in reality, when wood is used in this process are quite higher than even natural gas stations. And if we talk about biomass, we talk about heat supply and not electricity production. And then we should take into account how well the process works. Thank you very much. That is all from me. I would like you to keep in mind for sustainable development.
Thank you very much, Māris. The next speaker will be Oļegs. He is a colleague of yours in the energy field, and he will try to answer the question: is cogeneration something like a new wonder of the world, or is it like a regular part of our energy generation system? Microgeneration or cogeneration sounds like something new nowadays, but it is an innovative solution that we should definitely embrace, and we shouldn't be afraid of that. As far as I know, there are also students of Mr. Linkevičs among the participants, but today he will mainly speak not only to the students, but also to potential investors and other stakeholders. Thank you very much for the introduction, Mr. Bogustovs. Nuclear security is not a joke, it's not a fun deal. I'm also a professor of the Riga Technical University, as you know, and my scientific interests are related to technologies for electricity generation, including nuclear technologies and nuclear power plants. But my educational background is not related to nuclear sciences. However, thanks to my teacher, engineering Dr. Balodis Gavars, who used to be the main engineer in Salaspils nuclear power plant, I also gained invaluable knowledge, and I can transfer this knowledge to my students. I give them insights in nuclear power generation basics. I have also been involved in the project of Visagina nuclear power plant. I was involved in this project until our Lithuanian neighbors decided, however, to give up on the project of constructing Visagina nuclear power plant. So I am really happy and pleased to hear that Fermi Energia is, however, bringing further the nuclear agenda in the Baltic states, and I hope to get more involved in this project. Today, I'm going to talk about low-power modular nuclear reactor technologies. Unlike the before mentioned Visagina nuclear power plant, I believe that low-power modular nuclear reactors are more suitable for microgrids as present in such countries as Latvia and Estonia and Lithuania. It is to note that Finland is currently developing a large-scale nuclear power plant. The project in Finland was started in 2005, and at first it was expected to complete the project within 5 years, but the project in fact will be completed only now or in the upcoming years, and the budget was exceeded by around 10 billion compared to what was expected originally. So why I'm such an advocate for small-scale modular reactors? Why do I believe that SMRs, or small modular reactors, are our potential solution for energy security? Small modular nuclear reactors are nowadays defined as nuclear reactors with power between 10 to 300 megawatts. They are characterized by higher degree of modularization, standardization, and industrial constructions. To maximize the intensity of serial production, or so-called series effect. The series effect is actually the reason behind the cost effectiveness of SMRs. Due to the modular approach, mass production, simplified construction, standardization, and harmonized licensing process, it is possible to achieve the so-called series effect to compensate for the disadvantages caused by the SMR scale effect. For instance, Poland could benefit from 25 SMRs, or Estonia could deploy 2 SMRs, and as a result, it is possible to use mass production or serial production and achieve cost effectiveness and the so-called series effect. So what are the advantages of SMRs? It is a good solution for small-scale power systems in such countries like Baltics with relatively low power consumption and relatively low demand. We also don't have market players or investors that could invest billions in our energy market. So main advantages include modular or standardized approach, simplified design, serial production, cost savings, easier licensing and certification procedures. Also, construction is shorter. It won't take like 15 years as it was in case of Finland. It could take from 5 to 7 years or so. SMRs are easier to be transported in parts to the construction site. Such technologies as used in the SMRs usually are equipped with passive safeguards and safety features, and no electricity are needed to operate them. For instance, if an SMR is erected somewhere near the residential areas, it is of utmost importance to consider all the safety and security aspects. The passive safeguards and security features involved in the latest generation SMRs are to ensure that everything will be safe and sound. SMRs include actually a group of technologies. It is not just one technology, but several types of technologies and approaches. They are based on the so-called conventional large-scale nuclear technologies. For instance, light water nuclear power plants, for instance, boiling water power plants, or high water pressure power or pressurized water power plants. It is possible to erect or construct SMRs as a monoblock solution or as a multi-modular SMR, which consists of several smaller modules. Another option is to have SMR that at the same time can generate hydrogen. This is probably a future technology. Among the types of SMRs and technologies used in them, I have to mention also generation 4 SMRs. They use innovative nuclear reactor technologies, including those present in fast neutron reactors. They include many concepts that have been studied by the Generation 4 International Forum. And another type is micromodular reactors with power below 10 megawatts. Without going into further detail, I would simply like to, name a couple of SMRs. BWRX 300, Hitachi. It was also mentioned by Kalev in his presentation. It includes boiling water technology. UK SMR is Rolls-Royce with pressurized water technology. Let's have a look at the GE Hitachi BWRX 300 technology. The original power of the prototype was around 1,000 megawatts, but the power was reduced to 300 megawatts. This reactor uses boiling water technology with only one with only one circuit. There is no recirculation pump. Such a simple or simplified technology helps to ensure that even in case of emergency, it is possible to provide for passive cooling. So passive cooling is ensured without any intervention from the operator. Estonia intends to construct 2 or even 4 such type of reactors in its nuclear project. An interesting new approach is French NUARD project or French NUARD reactor. This is a reactor of very interesting construction. The pressure vessel with a band is contained in a seal protective housing and submerged in water to ensure passive cooling. The pressure vessel itself is integrated both with the nuclear fuel, that is the active region, and submerged control rods. What is interesting is that it also includes pressure control mechanisms, circulatory pumps, and compact steam generators, all of it integrated in one housing of the pressure vessel. This is quite an interesting reactor for construction-wise, but it's quite complicated also as we talk about the disadvantages. Let us talk about Generation 4 reactors and their design. On December 21st last year, world's first Generation 4 nuclear power plant was connected to the grid. It is in China, HTR-PM reactor. It includes high-temperature gas-cooled nuclear reactors with graphite-coated spherical uranium elements. It uses helium gas. This is HTR-type reactor. Active cooling is ensured by helium, and the whole system consists of 2 reactors, and both of them operate one turbine. Since high temperatures are reached, This reactor is also capable of producing industrial heat and probably also could be used for hydrogen production. So here is another example. This is rather, well, to have fun of it. There are the so-called floating nuclear power plants present in China and also in Russia. Russia has constructed a floating nuclear power plant in form of a ship, but as far as we know, notoriously, there's a great saying about Russians and their warships and where they should be headed. As to Latvia, in 2010, an interesting study was conducted regarding a potential construction of a nuclear power plant in Latvia. The study reviewed feasibility of constructing high power generation 3 nuclear reactors and low power reactors from generation 4 in Latvia. The construction site, as it was established, had to be located by a large source of water supply. So therefore, 3 feasible locations were reviewed by the Baltic Sea and by 2 larger lakes. And as part of the study, several conclusions were made. So first of all, public consent is needed to start a nuclear program on the national scale. Latvian public is less positive regarding a nuclear agenda in Latvia than it is compared to Lithuania and Estonia. Nuclear program could be successfully initiated only if a special law is passed by the Cabinet of Ministers. So I know that Estonia has already started drafting its nuclear law. In Latvia, we don't have any such legal enactments. Well, an important step, or I'd say even the first step, is to choose the right location for building a nuclear power plant. Usually it takes up to 3 to 4 years. An independent national nuclear safety inspectorate would be required with at least 20 experts. I know that Lithuania has established a nuclear safety inspectorate and regulatory authority. And Estonia is also on the way of establishing such an inspectorate. A specific national scheme for high-level radioactive waste management is necessary. It is of utmost importance. So before starting any further steps, it's necessary to consider what we do with nuclear waste when it's generated. Previous speakers talked about European Green Agenda. It emphasizes development of solar and wind energy in Europe. Solar and wind energy is expected to cover power capacity and baseload. However, we have to take into account that wind and solar energy capacity is not sufficient and it is unstable. On the one hand, we need to think about ways of compensating the lack of capacity and cover the excessive consumption needs. So everything that cannot be covered by wind and solar energy. But on the other hand, if we have a mix of wind, solar, and nuclear energies, sometimes nuclear energy capacity could be reduced in order to use wind and solar energy sufficiently and to gain full benefit of it. OECD has performed a study and projected nuclear LCOE costs for plants built in 2020 to 2025. So the calculations you can see on the slide are quite similar to those that we have calculated with 300 discount rate and 1000 discount rate. The prices indicated here are actually quite good or reasonably good. It has to be noted that nuclear power plants, unlike wind or solar plants, take more time to be constructed. So wind or solar power plants usually, however, are in operation for 20 years, but nuclear power plants can be operated for at least 60 years. At the end of my presentation, I would like to touch upon the EU delegated acts and taxonomy. According to these delegated EU acts, nuclear energy and natural gas are considered as means to phase out fossil fuels and move towards a climate-neutral energy. Therefore, it is expected to allow construction of new nuclear power plants and natural gas plants during the transition period, and we still have time to do that.
Thank you very much. We'll have numerous questions now. If Māris Balodis hears us and he wants to get involved, maybe both of you could tell us if today in the real life, do you feel attempts to, I don't know, choice of locations, a short list of locations? Are there talks of investments? Do people really believe that Latvenergo will be the ones that can carry it out? And who could it be? Or is it on the other hand just talks and dreams of scientists? Well, as the previous speakers mentioned, Latvenergo cooperates with Energia, and they're looking at territory in Estonia as well. Electrum work in Estonia as well. ICONDE has a slight advantage in comparison to Latvia. In Estonia, if you build a nuclear reactor, you have to dispose of nuclear waste. So, and this level is of the ground level that has to be dug up for nuclear waste is quite low in Estonia, 2 to 3 meters. So that's an advantage. But referring to I referred to a study. There were 5 propositions of places, but they were already talked about during the Soviet times. Artis Kruskops, my colleague, I hope he's listening to me now. So in Pavilost on the west side, before Ignalina was built in Lithuania, there was a plan of building it there in Pavilost in Latvia. And that's why I just wanted to say that these places have already been studied. So if we compare the work done by Fermi and Energia, how many specialists they're recruited for studies, topography and geological studies in collaboration with municipalities. Because in that year in Latvia, there was really no communication with municipalities with opportunities to build these projects. So Fermi Energia, with their 2 to 3 municipalities, had an ongoing dialogue with them, and they were involved in the process, and people expressed their opinions. Andris is asking a question in the chat. I'm not sure if Andris is a geologist or a physicist, I'm sorry. So he says that nuclear waste should be stored in somewhere in Latvia where there's clay, not rock. So can someone from the technical university give a mark to Andris' statement? Well, not really. I'm not really a geologist, but it's really hard for me to answer this. But as far as I know, in Finland and Sweden and the US, they are actually buried deep beneath the ground. So he's writing that clay is hermetic, but rock is not. So, but here, as it was with gas terminals. So if every country will build their own ones. So previously, countries wanted to make shared ones, but of course that was more expensive back in the day. But how would you say, is it strategic for geopolitically, strategically important for each country to make their own terminals? And how is it regarding with our experience with disruptions to supply chains and a lot of different factors? So why should we build it with Estonians? Why can't we just, from the sovereign perspective of our country, why shouldn't we build our own ones? From the perspective of our sovereign nation, of course, I would be really happy that we built our own nuclear reactor. I would even be ready to live next to the reactor if someone else doesn't feel safe. But of course, first and foremost, we should talk to the people, the society. If we compare the view of on nuclear in society in Estonia, we see that the Estonians have done their homework and they are much more positive towards nuclear. Of course, these MMR technologies allow us to build, for example, 2 reactors in Estonia, 2 in Latvia. But of course, we should take a look at the economic perspective. And if we talk about geology, from a geological perspective, Latvia can easily store natural gas in the depth of 800 meters. But for nuclear waste, there is a shaft where you have concrete shells, and this used nuclear fuel is supposed to be stored for 100 years. Of course, we haven't experienced the 100 years yet, but continuing your idea that it is safe and that we should use it, and it's something that we haven't yet mastered and haven't yet learned to just see it as something safe. So now we have the next speaker. We have Wade Ellison, who has numerous books that he's written already. So today we will read one of his books in a shorter version.
Okay. Well, we've already learned the problem is not only choosing the technology, of which there are many, but we also have the problem of half a century of telling the world that nuclear is terribly dangerous and they don't want to know about it. And suddenly we need to persuade them that it's not only safe, but it's extremely important for our future. Now, this isn't the first time in the history of the world that this has happened, because in the last 3,500 million years, the life has learnt a lot about energy. Can I have the next slide, please? There we are. This is the last time there was a major confrontation, and we overcame the objections of the Green Party, and we persuaded them to take fire into the home. And that was very dangerous, but it was very important that we did that. And we took the public with us. This is about 600,000 years ago. And in those days, the Green Party were right because fire was dangerous, but we still had to do it. And today, the Green Party is wrong because, in fact, fire is much more dangerous than nuclear energy and radiation. And that is what I want to discuss. Can I have the next slide, please? Energy is governed by 2 strict scientific laws. Both of them are really very simple. First, you can't make energy. You've got to find it from somewhere, and it's got to go somewhere as well. So we call all sources of energy fuel, and what we need are the primary sources of energy, because once we've got a primary source, then we can make secondary sources like electricity and hydrogen and so on from it. So we're looking for primary sources of energy or fuels. And the second law says that if energy is left on its own, it will roll downhill. So if we see a rock on the top, we say, oh, put that up there. And why hasn't it already rolled downhill? This is sort of obvious, but it's called the second law of thermodynamics. Similarly with heat, if you have a cup of hot coffee, it'll go cold. If you had 2 cups of lukewarm coffee, you can't make 1 cup of hot coffee out of them. You can't do it. So what we're looking for when we look for energy is the hottest coffee, the hottest source of energy, because with them we can make other sources of energy relatively simply. Can I have the next slide, please? But that then brings us to the problem of safety, because the energy has to be under control. And I'd rather not use the word safety because it's got emotional. It's a matter of control. We need to control when we use the energy and what we use it for, and to turn it off when we don't want it. So many sources of energy, possible sources of energy, either have already dissipated or we have difficulty in controlling them. And here we see 2 famous examples of fire getting out of control, in one case after having been stored for over 800 years. So if we look at the universe as a whole, we'll find for all possible sources of energy, there are very, very few that haven't already completely discharged or which we can't control. Now, the next slide, please. The universe, we'll zoom in on where we are in a minute, but the universe is huge and empty. And in fact, it spans 41 powers of 10 in size. And if we look out in our own world, we can see our galaxy down to the smallest things we can see under a microscope. That's about 21 powers of 10. Sorry, 26 powers of 10. That's the range in blue. But we can't see the electronic atom, which is 100,000 times smaller, or the, sorry, I don't want can we go back? Unclick, that's right, and back again, and back again. Right. So we can't see the smallest, either the smallest atom or the nucleus, which is 100,000 times smaller than the atom. So where is the energy? Well, can I have the click? 1 click, that's right. We live with the energy that comes from the sun, and it comes down to us as humans on the level of a couple of meters, and that is the energy source that we have lived in up until the early days of through the Middle Ages, and then, but life was pretty miserable under those conditions, and life was very short and miserable. Can I have the next click, please? So then we discovered fossil fuels, which also used the energy from the sun, but preserved geologically in the form of atoms and molecules of carbon buried in the earth, deep frozen as it were, and this gave us energy which was 10,000 times more energy density, and is available 24/7, and it provided steam and other engines, and it was rejected. But it was rejected in 2015 because of the effect of its emissions. You can have the next slide, next click, please. So then we come to nuclear energy. And the question is, where does that come from? Well, leaving aside fusion for a moment, the energy of the uranium and thorium that we are using in nuclear energy is generated in events like we can see today in the universe outside, for instance, as was seen in the Crab supernova, which exploded in 1054, or rather it was seen to explode in 1054 by Korean astronomers. And although it was 500 million times further away than the sun, this explosion was visible in broad daylight for 23 days to the Korean astronomers. And that's a picture of that explosion as it's seen today, as seen by Hubble. And that generates uranium and thorium, or such explosions before the Earth was formed is responsible for the uranium and thorium in our world today. It has 1 million times the energy density of the fossil fuels, but it's available 24/7 and it has no emissions. And also non-trivially, it's much more widely spread around the world than the fossil fuels. So many of the political problems that fossil fuels create will go away. Can I have the next slide, please? It is difficult to realize, to understand just how small the nucleus is. It's 100,000 times smaller than the atom. If you stand on the edge of an atom and you look at a nucleus, you wouldn't be able to see it. In fact, you'd need a telescope with a magnification at least 1,000 in order to see it. So it's incredibly small, and essentially nuclei do nothing. Only one nucleus in 1 million has made any change in the last 5,000 million years since the Earth was created. And that's why this enormously powerful source of energy was not even known about until 1896. Can I have the next slide, please? And it's incredibly safe. And it's incredibly safe because each of those nuclei are surrounded by an electric field which prevents them getting anywhere near one another. So this is on a log-log scale, and it indicates that not only is the nucleus incredibly small, but you need a temperature of in excess of 10 million degrees in order to get two nuclei anywhere close to one another. So one day we will perhaps have nuclear fusion, but at the moment we're much better off with nuclear fission. Can I have the next slide, please? So in fact, there are only 3 candidates for sources of energy. The first is what we used in the pre-industrial era, which is wind and solar and hydro, bio, wood, and also the effort that we could get by talking to animals and other humans and engaging them in teams and slaves and so on. This was part of the way in which humans became more powerful than individual animals. But the energy density, and you can calculate this, for instance, this figure actually comes from the energy density of 1 kilogram of water behind a 100-meter high dam is very, very small. And it's accepted. These are renewables, they're accepted. People like them, they're not frightened of them, but they're intermittent, weak, and the plant to use them is huge, has to be huge, and it's very damaging to nature. Can I have a clip, please? So then we got to the Industrial Revolution with fossil fuels, with a much higher, 10,000 times the energy density. Then the fuel needed for all the energy that people need in a lifetime is like 500 tons of coal each, as opposed to 10 million tons of water behind a 100-meter high dam. It's on a completely different scale. But most important is that coal was available 24/7, and I said that anywhere, but it was only for those who had access to fossil fuels, not to those who didn't. But the problem was emissions and not very good safety. Can I have the next slide, please? And so then we get nuclear fission, uranium and thorium, where the energy density is something like 20 million kilowatt hours per kilogram. That assumes that all of the nuclei are fissioned. And then you only need 1 kilogram of such fuel per person for to power, give them the energy for a lifetime. It's available 24/7, like and anywhere, like fossil fuels, and it's much better safety, and we'll go into that more in a minute. What's the problem? The problem is fear and poor education, and that people don't know anything about it, and it comes from pre-solar supernovae. This is really the comparison that is needed to evaluate the use of nuclear power. Now, the next slide, please. So what about its safety? Well, everybody's aware that there's a great thing goes on about Chernobyl, but the animals in the evacuation zone at Chernobyl, they don't seem to be aware that there is a problem. There's radioactivity there, but they're thriving. In fact, they're much better off now than they were when there were still so many humans around. They must do they know something that we don't? Well, maybe you might say maybe they don't know something which we think we know and is actually mistaken. And perhaps nuclear radiation is harmless at low and moderate doses. Can I have the next slide, please? That's an enormous subject on which we could talk for ages. But people already know the effects of, or the benefits of nuclear technology, because it's been helping with health for 120 years. And the name of Mary Curie is very high on people's a list. Can I have next click, please? Click. Oh, well, something's gone. Can you go back? No, there's meant to be something in between. Anyway, I can tell you. The problem was everything was fine in Marie Curie's day, and medicine was making great progress. But as a result of the Second World War and the Cold War, humanity lost their nerve, and bogus science and over-regulations. The regulations were tightened by a factor of 700 without any scientific justification. This was all political, and people were so frightened of radiation that they demonstrated and argued, and so that the regulations were made absurd, and they still are absurd. But this is another subject. Regulation should be based on science, firm science, and this change needs to be made today. These regulations, the situation can be explained in a simple diagram. Next slide, please. In this diagram, the area of each circle represents the radiation exposed in 1 month. And the red circle is what the tumor, somebody's tumor gets when they are receiving radiotherapy. And that is fatal to the tumor, and that governs the level of the exposure that is given. So that is red for a good reason. The yellow circle is the dose which people experience, or rather the tissue around the tumor gets, and people survive that. It may get hair may fall out and have scars and so on, but they survive it occasionally, very occasionally, a few percent chance of getting a cancer there, but it's unlikely. The green circle is the radiation dose from which nobody at Fukushima, nobody at Hiroshima and Nagasaki received any known serious result, and from all work in the laboratory and so on is known to be safe. It does not cause cancers or any other serious things, and that is the level of 100 milligray per month, or millisievert per month. The small black dot is the level which is currently 1,000 times smaller, which is supposed to set the level of current regulations. And that has caused a great deal of suffering. It caused the evacuation at Fukushima, which was quite unnecessary, and it causes enormous compensation payments to be made, upgrades of reactor designs which were unnecessary, or justified by paper improvements in safety, which are completely unjustified in science. Now, the next slide, please. So let's put things in perspective. This is a graph which shows this is from a UK government website showing the total monthly offshore wind power output. This is offshore wind, so this is the best form of wind power over a month. And this was March this year. It wasn't. It was the one that existed at the time that I looked at it. And you can see that for several weeks, it is pretty close to being at the level of 10 gigawatts for sometimes up to a week. Can I have the next slide? Then at the level, that's right, then the level at the time between the 21st and the 28th of March, the output of wind power dropped by from 10 gigawatts down to 1.5 gigawatts. Now, the physics of wind power is relative possible source of maximum energy is relatively simple to calculate. And when the wind drops by a factor of 2, the power drops by a factor of 8 because it goes by the third power of the wind velocity. So wind only has to drop by a factor of 2 to go from 10 gigawatts down to 1.5 gigawatts. Now that is an amazing amount of energy. That's 8.5 gigawatts of energy not available for a week, 176 hours. That's 1,500 gigawatt hours of energy. That is the same as 1,700 Beirut bombs of the kind that blew up in 2020. And the public have got to realize that when you start integrating, when you start storing energy, it's an enormous amount of energy one's talking about. It's on the scale of so, can I have the next slide, please? Now, this is something I don't hear enough people talking about. There is no, if you have enough nuclear power, you don't need another source of power. But the demand, electricity demand, goes up and down, according, for instance, this is not real data, according to the blue graph, it goes up and down. And if you ran the nuclear power to match the peak electrical power needed, then at night and when less power is needed, you can make desalinated water, you can make hydrogen, you can, of course, you can always provide heat for industrial processes and so on. But if you have nuclear power which is matched to the maximum electrical power needed, then you don't need another form of power. If you have molten salt reactor, then you can deal with short-term excursions using the thermal capacity of the salt. Can I have the next slide, please? One of the big problems, I think, in public perceptions about energy is that the public thinks that what you must have is carbon capture, or you must have big batteries. But technology is not that, and science is just not that easy. And getting batteries which are big enough to store the amount of energy that was equivalent to the Beirut bomb involves some very, very dangerous storage of energy. And the batteries, electrical batteries, have, particularly lithium batteries, are in a lot of difficulty with their safety requirements. So there have been a lot of safety, a lot of battery fires, not only here in Australia, where this is the biggest battery in the Southern Hemisphere, but also both halves of the largest battery in California have failed in the last year. And in Liverpool, a battery blew up, and the same in Beijing, Arizona, South Korea, and that's a big problem. Whereas nuclear, there's only one situation with a loss of life in the last 50 years, and that, of course, was at Chernobyl. So, next slide, please. The question is, what about the waste? Well, what indeed? This is a bogus question that doesn't prevent a lot of people asking it, and a lot of people earning a living and getting fat contracts answering it. First of all, there is very little waste. If you look at the amount of nuclear waste per person per day, assuming that you have 100% nuclear community, then the personal waste of person is about 1 kilogram, and the amount of nuclear waste is much smaller. Both forms of waste should be recycled, particularly because in the case of nuclear waste, it's only been 1% used, and so it can be recycled until it's very much smaller amount of. And in the case of personal waste, it can get recycled on the land, and it's a good form of fertilizer. Storage, you can store nuclear waste for 600 years after recycling, and after that it becomes completely normal. Personal waste is released into the environment. It's certainly not safe. It spreads disease, and is therefore contagious, whereas nuclear waste, nuclear radiation, is not contagious. There are terrible stories from Fukushima and indeed from after Hiroshima and Nagasaki of people being frightened of contagion by nuclear radioactivity. It does not multiply, it does not spread. Public understands nothing about nuclear waste. In the case of personal waste, all children from the age of 1 or 2 years are required to know what to do. In fact, we don't let them out into society until they do understand it. And this is how we deal with a serious problem. It should tell us how to deal with a much less serious problem, which is nuclear waste. So the world death toll from nuclear waste is essentially per year is none, and from personal waste is millions per year. Have the next slide, please, which is my last, I think. So it's all about fear, and there's a nice quote here: fear does not prevent death, it prevents life. So what we need to study, and we have to persuade people, but a lot of people get salaries from looking after fear, some things which are not there. I have written 2 general popular books. There's no heavy maths in either of these. They're meant for people to understand. It needs to be studied and looked at carefully. I've added here 2 references which discuss things in slightly more detail, and including challenging the priesthood of radiation protection. There's a whole business of preventing people being affected by radiation when in fact it's not going to affect them anyway. And that's all. Thank you.
Thank you very much, and we are happy now that you shared these links. We will share it also to people later, so they will go and read these books. And definitely you gave us a great list of arguments we will use, and it is true, also in our society, we have to put the arguments ahead and make this discussion lively, but also based on real facts. So thank you for giving real facts to us as well. Real facts will continue. There will be more, okay, so sorry, switching to Latvian.
Well, sorry, I'm switching to Latvian, and I was simply carried away by the wonderful presentation by Mr. Wade Ellison. We will continue with real facts, but it will take place after the break and in the second part of the conference. So we will not only approach real and serious facts, but we will also have a look at a funny video. But the next presentation will be dedicated to institutional and political framework, as well as legal framework. Gunnars Valdman is a student of doctorate studies, will give an insight in institutional and energy policy framework for possible introduction of nuclear energy in Latvia. So how far do you think we are from introducing, a nuclear power plant in Latvia? Could a nuclear power plant be opened in Latvia in 5 or 10 years' time? Well, definitely no less than 15 years. And I will tell about the steps, how we could approach the nuclear deployment in Latvia. Ladies and gentlemen, thank you for inviting me to have a stand in this conference and to give my presentation. We can be blamed for many things, but in the energy sector, we always try to think about cooperation with other industries. We are really interested and in cooperating with other industries and in different ways to complement our activities. So I would like to give my presentation on main strategic and political preconditions for deployment of nuclear energy. And this presentation has been developed not only by me, but also by our strategic partners, including Latvenergo, which is a power supply company in Latvia, and also representatives from the University of Latvia and other stakeholders. We want always be on the same page and always complement each other in our views and opinions. Latvenergo is a pioneer and leader in the development of a strategic framework. But when it comes to key strategic preconditions for deployment of nuclear energy in Latvia, I would say that there are 3 main directions of activities that we have to take. Well, 3 main groups of preconditions. First of all, it is about legal preconditions. It is necessary to perform different preliminary
nozare, kurai ir jādefinē skaidri tās status likumdošanā, Un jāpieņem arī skaidri politiskie lēmumi.
So this is a new industry, a new sector, and so new legal enactments have to be developed. So I will go into details, but at first I will talk about different restrictions that are applicable to radioactive substances and materials. Such materials are in a way unsafe, therefore the accessibility to such materials and substances have to be restricted and only limited to particular scope of people. The next group includes administrative and technical preconditions. A specific administrative capacity is necessary, and also relevant laws and regulations have to be drafted. A specific institutions have to be established, and they require an expertise dedicated to nuclear safety and compliance, as well as monitoring of these aspects. Third category is political preconditions. Well, political support and agreement is necessary not only among political elite, but also among general public. Broad accessibility of information has to be ensured, and there should be a public analysis of risks, benefits, and costs. Probably a popular vote or referendum should be organized, or other type of public discussion has to be ensured. Let us go into details in legal preconditions. First of all, we need a legislative enactment on constructing a nuclear power plant in Latvia. So this law on the nuclear power plant and its construction has to give mandate for constructing a nuclear power plant, and also to regulate in detail the whole nuclear industry. The next legislative precondition is choice of construction site. This is not only a technical, but also a legal issue. We live in a democratic society, therefore we have to take into account not only our views and opinions, but also the views, opinions, and interests of our neighbors and other users of the same area. If we want to sacrifice the interests and legal benefits of a particular group of society or inhabitants of a particular area, we need to compensate them for the disadvantages in one way or another. In case of a nuclear power plant construction, most likely we will have to take the route of compensating somebody for the disadvantages caused. But everything has to be stipulated in detail in laws and regulations. The next task is to establish a nuclear safety supervisory body. That would be an institution responsible for personnel certification, licensing of specific aspects related to nuclear power plants. Probably these responsibilities can be delegated to an existing institution, or a completely new institution could be established. It might sound that it's easy task to do, just simply adopt a law or regulation. But in fact, it is a legislative process can be quite lengthy, especially if there are some misunderstandings, some disputes, opinions do not conform with each other, and the whole process can become quite lengthy. When it comes to training and educating a new type of specialists, not only in nuclear energy and nuclear physics, but also in related fields, it also takes quite time. We need new specialists in heat energy who could work in the nuclear power plant. We need to train and educate lawyers and other specialists to work in a specific supervisory body. We need to train and educate also specialists from other supervisory and monitoring bodies and inspectorates. At the same time, everything should be regulated by particular legislative enactments, and the whole procedure should be regulated starting from initiating the operations of the nuclear power plant up to the waste management and decommissioning of the power plant. Administrative and technical preconditions in many fields overlap. They are like an umbrella to cover several fields. Well, administrative preconditions are not so much related to legal aspects, but rather with different material needs, like ensuring workforce. So we need to consult other countries that are experienced in the field in order to find out how many new specialists we would need to start operation of a new power plant. According to experience mentioned by some foreign specialists, we have heard that it's around 75 people that are needed to staff a new nuclear power plant. For us as an industry, as an energy industry, it is a positive development. We are looking for ways of recruiting new specialists. We are looking for ways to improve the image and the salary in our industry. In general, we believe that energy sector is highly competitive as an employer, and this is a sector that also helps to improve the quality of life, both for public and those involved in the sector directly. On the one hand, it will be a challenge to ensure the training and education for all the necessary workforce and specialists. But on the other hand, well, it could become an invaluable resource in the future. At the moment, we don't have a specific study program or laboratory dedicated to nuclear issues. So a new curricula should be developed, new laboratories should be equipped. Current study programs should be reviewed and revised to include additional content related to nuclear issues. And we should also think about ways of recruiting students for the newly made nuclear study programs. When it comes to operation of the nuclear power plant, it is necessary also to think about protective zones, sanitary zones, increased safety zones, how to introduce such areas, how to maintain them, and how to defend and protect their physical security. It is also necessary to think about ways of training specialists working in the nuclear power plant, how to provide emergency help in case of some disasters or incidents. Well, and we also need to think about natural security and defense. Nuclear energy is, an issue of national security, and it can be turned against us to threaten our safety and security. So we need to perform a thorough recruitment procedure and to check all the workers working in the construction site and all the potential employees of the MPP. It's not so much about specifically related to nuclear energy, but any type of energy. Energy is an issue of national security. We have seen how energy infrastructure can be used as a way of reducing countries' independence. For instance, we have seen several examples in the current war started by Russia in Ukraine. Other aspects to consider is agreement with other parties involved for balancing the load and capacity of the nuclear power plant, emergency compensation, conditions for market participation or financial guarantees, as well as we need to consider conditions for infrastructure funding, for instance, construction of new power transmission lines or new roads, development of atmosphere and water basin monitoring system, and other. It is also necessary to agree on conditions for using municipal or common water basins, like the Baltic Sea. The same applies to using transport system and common public roads. If a specific infrastructure is built and it is dedicated for the needs of the nuclear power plant, then we also need to think of how to balance its cost effectiveness. So here you can see in the picture two strategically important pieces of energy infrastructure that are intersecting. One of them is a natural gas pipeline from Klaipėda liquefied natural gas terminal, and the other is two-thread cable, electricity cable. So here are also places, as you can see, where those two strategically important, strategically vital objects intersect. As to the key political preconditions that are required for introducing of nuclear energy in Latvia, we need to reassure the public that nuclear energy is safe. And we need not only to work with awareness raising among the public, but also among industry specialists. The industry is willing, the industry is looking for such decisions that are transparent, that are beneficial for the industry, and that have not been adopted in a hurry. The energy industry itself is interested in clear, transparent decisions. Only then the industry can be sure that the investments are safe and the industry can rely on the return of its investments, and its efforts will prove to be productive. So these are the first steps to be taken in order to start a power plant deployment in Latvia.
Thank you very much. But for making the wheel turn, it's usually the price or different geopolitical aspects that help. Of course, one thing is that you tell everyone, but all of a sudden, the situation in the world changes. But for example, Germany builds a gas pipeline or oil pipeline, and now you can't use it. So, for example, imagine the war ends and everything goes back to normal. Again, the energy is cheap, everything is easy. But imagine we don't think that the situation will change. And so is there an idea that there might be a reverse progression?
Recording stopped. Recording in progress.
I don't think that really applies here. The policymakers and regulating institutions should avoid the situation that we saw in the previous decade, where the prices couldn't really finance new investments in the field. And that's why we are in the present situation. Because on a purely technical level, if we look at how the prices have risen, we can see a correlation that in the previous years, manufacturers and nuclear operators in Scandinavia just closed the operation because the prices were not rentable. But human work in a society where work is valued, it just human labor cannot become cheaper. So these are limited resources and they shouldn't become much cheaper. So if we look at steel and wood, they are cheap and it doesn't show that it's good and that it's sustainable. So the next speaker will be quite interesting, especially for you, Adam Blazowski. He's from a country that we sometimes scold that they are not too creative or green in terms of energy because they use a lot of coal. But for Adam, it's an opportunity to show that Poland looks at smart solutions. And he's an expert on smart cities as well. So pragmatic and Polish. So two things that Adam will combine in his presentation. Please, Adam, the floor is yours.
Okay, welcome everyone. My name is Adam Boszowski. I'm representing Polish eco-humanist FOTA for climate. We are an NGO, a foundation. I'm one of the founders. As you mentioned, my background is a software engineer. I have been working all my life with smart city, energy efficiency, with renewable energy. So I am absolutely not any way related to nuclear energy, but we are environmentalists and we talk about nature protection and we talk about energy as a vital element of our life. And I will explain and tell you a little bit more about how we reached a conclusion that we need to talk about nuclear. So we started in 2019. We are a foundation, but we have currently a couple hundred people who are really actively supporting us and who see our cause as valid and interesting. Okay, so when we talk about climate change, we talk about how the challenge is very hard to ignore. We have to reduce the CO2 emissions, and the later we do this, the more we have to go into negative emissions in 2050, 2060, 2080. So you see this by this yellow part of the chart. This comes from IPCC data. So what does this mean? It means that our children and grandchildren and our grandchildren are going to build very expensive, very difficult installations for retracting CO2 from the atmosphere. So instead of building hospitals and building aqua parks and schools and kindergartens, they will need to spend significant amount of money on cleaning up our future environment. So this is not only about stopping emissions. We have to clean up. So you can imagine throwing garbage into the forest. It's not enough to stop throwing garbage into the forest. You have to go to the forest and you have to pick up the garbage in the forest. And why is this important? It means that we have to abandon the traditional green narrative about soft energy and reducing energy needs, because we are going to need much more energy right now than we need right now, because it comes from thermodynamics. If you make mess, it takes much more energy to clean up your mess than to make this mess. And since we have polluted our atmosphere, then if we are serious about stopping climate change and even reversing it, we have to use a lot of energy. So obviously, we all know what are the clean energy sources. This is not coal. This is not biomass. This is not natural gas. It's renewables and nuclear power. And this is very clear that we have to use all resources that are at our hand. Yeah, we are not in a position as a society to pick and choose and say, oh, we only want this or we want only that. The situation is so difficult that we have to use all. And this is only going to get harder. We in Europe can talk about energy efficiency, and we should, because there is plenty of inefficiencies in Europe. But even if we are really good at it, it's going to be dwarfed by whatever happens elsewhere. So this traditional narrative that we have to reduce, and we have to use less energy is true because it's valuable to save energy. But on the other hand, we have to prepare ourselves as citizens of this planet for a massive, massive increase in the needs for energy. This is related to the people getting out of poverty in India, China, Southeast Asia, Africa. And the West and the North should not absolutely ignore the fact that they have to reduce their energy consumption. But overall, we are going to increase. So we will need much, much more. And we find it detrimental to the whole narrative. There are a lot of green narratives that talk about future with much, much less energy. We think it's counterproductive and we think it's not realistic. It's basically telling the people in poor countries that, sorry, you have to stay poor because we have damaged the climate before you. So now you have to stay poor and you cannot grow. This is inhuman. This is against the principles of humanism. So we have to combine together the needs of other societies to lift themselves out of poverty, and we have to combine it with the protection of the climate. And historically, our movement towards clean energy systems is really going nowhere. So you can see the renewables have increased largely. This is great. This is good for us, but only in a small percentage. So the overall need for energy has increased. So even with the current development of clean power and clean energy, we are not able to catch up to the growth of energy. So we are effectively standing still in one place, and we are not moving. One of the reasons why this is the case is because in the West, we have allowed ourselves to shut down nuclear power, which is also low carbon, but is replaced by renewables and gas. So this is something that we see as a huge problem because this is ruining our efforts. It's ruining our efforts to decarbonize. So we as FOTA, and I was doing the calculations, we thought, okay, what can we do as an environmental organization that is the most forgotten topic? How can we stop something, or how can we prevent a bad decision that is the most forgotten but really impacts very strongly on the climate? And stopping reversing the shutdown of nuclear power plants, we figured out it's really important. So if you look at Germany, German reactor produces about 1 gigawatt. If this reactor is replaced by the current electricity mix in Germany, which emits about 430 gram CO2 per kilowatt hour. So just if I can extend the life of a German nuclear reactor by 1 hour, I can negate the CO2 emissions of all my life. So this sounds like a very worthy cause. So we as FOTA decided that it's an important thing to do. So we have organized a Polish protest together with some pro-nuclear people in Germany in a power plant, Philipsburg, Gronde. And then we went to Berlin to protest the nuclear phase out in Germany, in Berlin. This was all before the war, and people didn't really see this consequence. But right now it's very clear that this is happening, and this phase out, the nuclear phase out, is a disaster in the making for the climate and for the energy systems. The German emissions are increasing for the second year, and they will increase on the next year also. So the grid intensity is increasing. So this is what's happening. On the other hand, we are absolutely pro renewable energy. Except that the whole concept of renewable energy is very poisonous because it includes biomass. And wood and wood products accounted for almost 45% of EU gross inland energy consumption of renewables in 2016. And so as environmentalists, we are very much against use of biomass for heating the cities. If we allow this, Denmark is really leading this, and Denmark is really going for 100% biomass by 2035. This is a disaster for the environment because the demand for biomass is increasing so much that even very valuable forests are being cut. And there has been a very loud protest from Estonia. The Estonian environmentalists have issued a paper to Denmark that they are really burning Estonian and Latvian trees in their district heating plants. So we have to be sure that not every renewable source is really clean. So just the concept of 100% renewable energy system is abhorrent from the environment perspective, because we cannot destroy the environment to save it. And certainly biomass, it's okay for wind and solar in the right locations, but it's certainly not okay for us, for the biomass industry. And we see a huge increase of the biomass demand on the market, which affects. And nuclear scarce nature. I do not have a Polish translation for that, but I will translate that. This is on the vertical. I don't know if you see my mouse, but on the vertical, on horizontal lines, on the columns, we have coal and gas. Then we have renewables, and then we have nuclear. And then we value them according to fuel, length, and materials and emissions. So fuel per terawatt hour, coal and gas, they need a lot of fuel. Renewables, they need some fuel. Maybe for wind and solar, they don't need it, but for biomass, they certainly need fuel. Nuclear needs very little fuel. So that's an advantage for nuclear power. Land is, again, very little for coal and gas, but very large for renewables. Renewables need a lot of land, and nuclear needs very little land. If you look to a German power plant, on the area of 2 or 3 hectares, you can produce as much energy as all wind turbines in Denmark. So it's significant benefit for the environment if you have a nuclear in your energy mix, because this land sparing is very important. Certainly for biofuels, it's much better to create synthetic fuels with nuclear than produce biofuels from farming, where you actually cannibalize the food production. And materials, it's coal and gas, they don't need much materials, but renewables, they do need a lot of materials, silver and steel and aluminium, and nuclear is very friendly per terawatt hour for materials. And of course, emissions. Renewables are clean and nuclear is clean, but coal and gas are very polluting. So in the end, if you look from the nature's perspective, we are environmentalists, then nuclear is really the way to go, because it has very low fuel demand, it has very low land, and needs little materials, and has no emissions. So it's really no-brainer for the environment. So we act, we do. We have started the campaign Save Climate, Support Nuclear in Poland. So hundreds and thousands of people have put this on their profile on Facebook and other social media. And this is how we help people to come out as pro-nuclear in an easy and a safe way. Because historically, if you were pro-nuclear, you were often attacked or confronted by anti-nuclear activists. Today, it's the other way around. Nuclear has a very large support for Poland, in Poland. And actually, if you are anti-nuclear, then you have to explain yourself. And among the climate environmental movement, it is not a good idea to be against nuclear, just as much as it's not a good idea to be against renewables, because our true enemy is coal and gas. What else do we do as FOTA? We are doing a program, Moratorium for Trees. So we fight, and this is our core project, we fight to change the law so that trees and urban trees are not removed, cut and destroyed, because we see this on a large extent, partly because the demand for biomass is growing so high. And the urban trees are really important because they are part of our critical infrastructure for climate mitigation and adaptation. They lower temperature in the cities, they provide biodiversity, and they keep water and when we have drought. So we have to consider both nuclear and trees our critical climate infrastructure. They are very similar. Both are disappearing for the same reason. Nuclear power plants are disappearing because people don't know why they were built and what is the reason they are existing. It's the same with trees. People do not know why the trees are important in the cities, so the trees are disappearing. The only thing in your mental model about the tree is that it can fall down and kill somebody, or that you can cut it. This is the main mental model of the people. And the same is with nuclear power. The only mental model about nuclear power plant for people is that it can explode. So this is a similar case where a very valuable technology or infrastructure like urban trees or nuclear power plant is wasted and not appreciated because we are not conscious that it's important for our lives and it's important for the climate. Other things, we are issuing open letters and getting signatures to the government about the drought in Poland. We have severe problems with the drought. We are investigating forest and biomass markets and the biomass industry to use the standards and FSC standards for biomass collection. Very often these certificates are completely bogus, and we really go to the forest, we make photographs, we show the auditors of the certificates that the local forest industry is not following the rules, and then they have to explain themselves and even sometimes lose the certificate, which means they will get less money for the material that they have. So they have to follow the rules by the European Union, and we do these investigations. And of course, we did a very widely discussed open letter of Polish scientists against closure of German nuclear power plants. We sent it, more than 100 Polish scientists have signed it. We sent it to the embassy, we sent it to the Bundestag, we sent it to the Academy of Science in Germany to really reconsider Atomausstieg and really consider climate as priority. Interestingly, this was completely ignored. We have never received a formal reply. Our protests in Berlin, we invited Professor James Hansen to the Brandenburg Gate. We also protest in Poland together with Extinction Rebellion, with Fridays for Future. This is a photo from our protest in front of a bank that wanted to support coal industry. So we are absolutely cooperating with climate movements because we have common goals. Sometimes we maybe differ on nuclear, but even then, we absolutely see no problem in cooperating together. And last but not least, we are one of the founders of a new European-wide organization that's called Replanet. Replanet is a coalition of eco-humanist organizations in all over Europe. And Folta was one of the first founders of this. So right now we have someone in Finland, in Sweden, in Belgium, Netherlands, Germany, Poland, and we are looking Slovakia, Austria. We are looking for similar, like-minded organizations. And our slogan is liberate nature, elevate humanity. And you can already see a very stark difference between traditional environmentalism, who was really anti-human, but we want to talk about both. We want to liberate nature and we want to elevate humanity, because it's not fair that some people don't have electricity in 2022. Yeah? Our most recent campaign is Switch Off Putin. I encourage you to go on Twitter and retweet it. We want to, we have calculated, we don't just shout, we really like numbers and we really have plan and we really have an idea how to do this. We want to switch off Putin and we want to cut Europe from fossil fuels from Russia. We have ideas how to do this. And I really encourage you to go to Twitter and see for yourself. Mark Linus, the famous environmentalist, has done a short video about how to do this, and he has the numbers. So I really encourage you to go to Twitter, Replanet.ngo. Let's Replanet, this is our handle. And if you want to follow us on Twitter, it's Photo for Climate and me, Adam Brzozowski. We are there, and we are available for you to answer your questions or help you or discuss. Maybe you think we are wrong. So we are also very open to this. We don't have all the answers, and we are absolutely, this is something that's characteristic for us, is that we are absolutely positive about changing our mind about things. And changing our mind about nuclear was very important for us. And actually, when you're wrong and you change your mind, it's not a moment, it's not something to be ashamed. It is something to celebrate and even appreciate, because you are wrong, and now you know you are wrong and you know more. So your knowledge is better. So this is what the modern environmentalism should look like. The modern environmentalism should be pragmatic. It should be not afraid of questions. It should not be dogmatic. And this is what we want to build, and we want to build it on the European scale. Thank you.
Thank you for being also pragmatic in the sense of not putting only blacks and white colors. Still, we have one quick question here from people who would like to know about this black substance, about the coal. How different is the percentage? Does it differ at all because of this Russian crisis of a local coal that is mined inside Poland and used for energy production? We had these discussions a little bit before. If we have some excuses maybe now because of the war, stick to the older traditions, don't fill up the promises we gave to ourselves for a green deal of EU and the world.
So 70% of energy in Poland comes from coal, and almost everything is domestic. There used to be an import from Russia and from Donbass, specifically from Donbass. This is really hard to explain. It's immoral to import coal from Russia that comes from Donbass. So this has recently been banned by the Polish government. So it's not legal anymore to import coal from Russia to Poland.
Yeah, of course.
The current situation and the gas prices means that it's much cheaper to burn coal than gas. You can see it in Germany, you can see it in Poland. So we have our coal power plants running at 100% right now because it's much cheaper than gas. So it's very unhealthy. But we have been protesting against the idea of gas as a transition fuel over nuclear for a long time, because this is exactly the result of this wrong thinking. If we allow ourselves to transition from coal to gas, then we are going to lock in ourselves for the next 40 years because you have to build infrastructure, pipes, and new plants. This is a disaster that we observe right now in Belgium, for example. Belgium wants to shut down 5 reactors, which is like 30% of their energy mix. It's horrible. They're going to replace it mainly with gas. So, this coal imports from Russia are right now banned. Putin also closed our gas supply. So we are completely putting off as we speak.
Yes, and hopefully we will manage, beside the realities we will face anyway, it is going to be politics as well inside this, all decisions we are discussing today. Mm-hmm. Nevertheless, Adam, thank you for being so kind to give us the nice, actually realistic picture of your country, which very much is flagmanship in actually this region as such. So hope to.
If I can just add one sentence.
Of course.
In 1989. We have been building our own nuclear power plant, Šternbergs. That's by the north in Baltic Sea. And this project was killed by the Solidarity movement, which won with the communists, because Solidarity was very well established with the coal industry. And together with environmentalists, they have killed it. And because this project was killed in 1991, a new coal power plant in Opole, Western Poland, was built. So instead of building a nuclear power plant, we have built a coal power plant. And this is the legacy of the old environmental movement in Poland, and they have to live with this. On the other hand, Slovakia was in the same situation. In Slovakia, they stopped the building, but then they continued. And now they are going to finish it. And in 2 years, Slovakia is going to have 100% clean energy in their energy system. So Germany is maybe going to get off coal in 2038, maybe. And Slovakia is going to be decarbonized in the energy sector in 2024. So just think about it and think what it means for the environment and the climate. Yeah.
So sometimes it is even better to be a kind of smaller country, not the big country. So in this sense, I'm for Slovaks, supporting their choice. And in a way, they are very comparable to Latvia. Actually, the size of the GDP of Latvia and Slovakia is more or less the same size. So good luck for your country's transformation. Good luck for our country's transformation. Nevertheless, we switch back to Latvian. Un nav Visvalds Grāveris ir ieņēmis ļoti interesantu pozīciju Liepājā, pilnīgi ļoti.
Mr. Visvalds Grāveris is actually now located in Liepāja. It is very close to the spot which was once considered as a potential location for building a nuclear power plant. It is near Pavilosta. Visvalds Grāveris used to work in the Institute for Solid-State Physics and at the moment he's working in an institution that is responsible for assessing safety of different things, and he will talk about a rocky road of nuclear energy in Latvia and globally. In fact, I'm not anymore active working as a safety and security expert in environmental agency. I am now retired. Briefly about me. I haven't been involved in nuclear energy, but I have worked with radiation throughout my all professional career. At first, I worked in researching of radiation effect in crystals in the Solid-State Physics Institute. I have also been involved in Latvian gamma radiation monitoring and early response system deployment and data monitoring for almost 20 years. from the point of view of radiation, I would like to explain why our road of developing nuclear energy is a rocky one, and it goes with ups and downs. Well, the history of using nuclear energy started with a dramatic event, bombardment of Hiroshima and Nagasaki. One might argue if that was necessary, but it was only after the war there was a thought of using this fantastic source of energy for peaceful purposes. There were high hopes vested to the nuclear energy. It was a new, practically non-depletable source of energy, million-fold more powerful than conventional sources of fossil energy. It was billion-fold more powerful than solar and wind energy. The whole atmosphere was euphoric, and people believed that there will be such an amount of cheap energy that it will be too cheap to even meter. But something went wrong. I don't know what happened and when we took the wrong turn, but the whole development of nuclear energy was halted. Well, as to the first reactors and nuclear power plants, so how fast we moved from the first reactor to nowadays. So the first reactor, which demonstrated the first chain reaction, was Chicago Pile 1. It was launched by Enrico Fermi, the extraordinary physician in experimental physics. The Estonian company Fermi Energia was named after him. In 1951, December 20, that is 9 years after Chicago Pile 1, in Idaho, the first experimental reactor was launched to generate electricity. It was EBR-1, with quite a moderate power of 0.2 megawatts of electricity. The actual period or the actual era of nuclear energy started in 1956 with launching of Calder Hall 1 reactor in the UK. It was built in 3 years. And in the upcoming 10 years, 23 more nuclear reactors were built in the UK. And the first reactor, Calder 1, was actually officially opened by the current British Queen Elizabeth II. Well, many people don't know the fact that Brits remain the leaders in nuclear energy on global scale until 1970. Until 1970s, and the lead was taken over by the US in 1974. It was taken over by Japan, 76 by Germany, 78 by France, and 1979 the Soviet Union became the global leader in nuclear energy. The maximum pace or the peak of construction of new reactors was reached in 1975. During that year, 40 new reactors were launched into construction phase. That is, one new reactor was started to be constructed in 9 days. Calder was built in 3 years, previous reactors in 4 years. But now the most modern European reactor nowadays was built in 17 years, and the total budget has increased the initial or original estimates by several billions of euros. It also has been taking quite a lot of time to finish the ITER reactor in France. It is quite a lengthy project. Nuclear power plants have been launched on submarines and on different ships and other vessels. But still, sometimes it takes years and years of actually implementing the nuclear energy and putting it into operation. So why is it so? It is because the anti-nuclear activists and the propagandists are very active and quite powerful. I know that we are lagging behind the schedule, so I will skip a few slides. So as to counter arguments, where some people claim that nuclear energy is bad, somebody says that it's dangerous. And here is comparison of nuclear energy and aviation. We are not afraid of stepping on a plane, but we somehow have unreasonable fear against nuclear energy. Some claim that nuclear energy is expensive, and here you can see the building costs of low carbon electricity. Even the even with the newly constructed Finnish nuclear reactors, it took so many years of building, and it will still be cheaper than other types of energy generation. Nuclear power plants have service life that is 2- or 3-fold longer than the service life of wind or solar power plants. The same applies to the argument that nuclear power plants take very much time to be constructed. Well, it was true with the first nuclear power plants, because there was no experience in building such a new construction. EBR took 4 years to be built, Calder Hall 3 years. But now we have had 20,000 reactor years of experience in construction. So it is not a lengthy process anymore. The exaggerated fear from radiation and the exaggerated misleading response is based on the wrongful hypothesis by Mr. Henry Miller in his Nobel lecture, and it was simply taken as a paradigm. Some say that nuclear power is not natural, but even Paracelsus, a scientist who lived several centuries ago, knew that medicines, or the difference between medicines and poison lies simply in the dose. There are no experiments to prove that radiation is dangerous if it's used in the correct doses. So here are a couple of examples from my experience in Latvia. So these examples are to illustrate that all the charges put on radiation are exaggerated and they are not substantiated. I started doubting the current radiation norms for the first time when I understood that rain, the rain in some places of the world is at least tenfold more radioactive than than the radiation standards or the radiation limits stipulated in our laws and regulations. So people live in with much higher levels of background radiations, and there have been stipulated in laws and regulations, and somehow they don't die off simply for that reason. In Daugavpils, there are the so-called snow white spheres, or these white spheres that monitor the radiation in the atmosphere. These are monitoring stations built by Finnish companies. The monitoring stations analyze several thousands of cubic meters of air to detect cesium and berkelium amount in the air. Cesium is a technogenic origin. Is of technogenic origin because it's not present from natural sources. And becquerel beryllium is a natural isotope that is present in nature. It is measured in millibecquerels per cubic meter. And the background radiation present in Daugavpils was much higher than previously considered recommended in some laws and regulations. Another proof for safety of radiation was demonstrated in 2016 in Helsinki in Radiation Safety Institute. The same snow white monitoring sphere detected billion-fold increase in background cesium radiation. And the director of the scientific institute in Helsinki, Ika Heimonen, in a press release said that only in case of a billion rather than million-fold increase in cesium background radiation, it would be necessary to think about measures of evacuating people. So she confirms that million-fold increase in background cesium radiation is not a problem, and it could be related probably to tests performed with nuclear weapons in Chernobyl or something like that. So Director Ika Heimonen confirms that only in case of a billion-fold increase in background radiation of cesium, it would be necessary to consider measures for evacuating people. It simply also means that the current monitoring systems are able to detect such levels of radiation that are really minimal. Unfortunately, different people who are against all things new, including nuclear power, or who are lobbying for other types of energy, are using this information and to monger fear amongst the society. Another proof for the safety of radiation was shown in 2018 in Getlini landfill. Increased radiation levels, so increased cesium level was detected. So it was like 6-fold above the upper limit stipulated in law, and there were heated discussions on whether it's possible to deposit, whether it's possible to utilize or deposit the respective waste in the landfill, or should it be disposed of in some kind, in a different way. And we as scientists calculated that in order to suffer from acute radiation syndrome at such level of radiation, the radioactive waste in the landfill should be eaten in amounts of several hundreds of kilograms. And it would take consumption of more than oral consumption of more than 1,000 of radioactive waste to die off that. I was also involved in the Kallemets program. That is a program for monitoring the pollution in Baltic Sea and global oceans. It is dedicated to radioactive pollution, and the Kallemets project involved specialists from all the countries surrounding the Baltic Sea. Many people probably are not aware of the fact that the Baltic Sea is the most polluted sea in the world when it comes to the content of cesium and strontium. It is, the level of cesium is still between 30 to 40 becquerels per cubic meter. However, during the research that have spanned over 30 years, no harmful pollution or no harmful effect on flora and fauna of the Baltic Sea was detected. Also, no harmful effect was detected on people living by the Baltic Sea. What is interesting is that the content of cesium in water reduces by half, not in 20 years, but even in 10 years. And alongside with the natural destruction, also cesium deposits accumulate somewhere in water. I am an expert who has always been involved in pollution monitoring in waters, and I was interested in the pollution levels after the Fukushima emergency and Fukushima catastrophe. When water reached the western bank of the United States, the internet was full of false news on fish dying off in crazy amounts. And I looked at the monitoring data, and it showed that cesium content in water after Fukushima catastrophe had increased by 2 to 4 times in the waters of the Pacific Ocean. It reached only 4 to 6 becquerels per cubic meter. It is a negligible amount compared to the natural activity, radioactivity of the ocean water. So the natural background radioactivity in ocean is measured in 12,000 becquerels per cubic meter. Unfortunately, we are running out of time. Could you please just try to wrap up your presentation? Here, I would also like to reiterate one more thing. A boy called Phys shared his thoughts on Facebook, and he compared natural radiation level with the level of Chernobyl. And he asked a rhetorical question, is radiation in fact dangerous? And if radiation is not dangerous, as we have been always told, then all the counter-arguments that to deny nuclear power and to object nuclear energy, they are all just useless and they are based on nothing. Probably we don't need all those exaggerated safety systems, and nuclear energy could become really cheap. Probably the most difficult thing is to admit that for over 40 and 50 years, the energy policy has been based on lies that have made nuclear energy a culprit. So you can also read an article on the internet, and it's called "Oh, those funny nuclear waste." Everything that I have to say about nuclear waste can be easily found on the internet, but what I can briefly say is that the amount of nuclear waste is incredibly small, it's tiny. And the requirement to dispose of nuclear waste in a very deep, geologically stable underground repositories, well, I believe it's unjustified. And it's simply giving up our positions towards the anti-nuclear activists. In fact, what is necessary is just 2.5 meters deep layer of water to prevent the radiation release from a nuclear power plant. The aim of anti-nuclear activists is simply to make things more difficult and to make construction of nuclear power plants more expensive, and not to give up on fossil fuel, because somebody is probably getting their money from fossil fuels. Well, what are my conclusions? So nuclear energy is one of the basic sources of energy alongside with fossil energies and others. But nuclear energy can be considered an essential source of energy. And according to laws of physics, one essential source of energy can only be replaced with another essential source of energy. So at the moment, we see quite high competition and increased activities by nuclear protesters. If we moved to nuclear energy, we wouldn't have to think of all the problems and challenges related to other renewable sources of energy, like solar energy or wind energy, which are still quite challenging to be generated, obtained, and collected. However, we somehow tend to follow the lead of the nuclear protesters, and we follow the lead of those who want to compete with nuclear energy for. If you remember the history of building and deploying of nuclear reactors, well, at first it took several years to build the first and the second nuclear power plant, and then in 1970s the peak was reached with several new nuclear reactors built in every 9 days. So it means that we could also build a nuclear power plant in Latvia. But the problem is not related to construction or finances, but rather the lack of awareness in society. We need to work with society. We need to break the stereotypes and biases against nuclear energy. Otherwise, everything is meant for failure. We need to educate the society that radiation is not as bad as some claim it to be. And also Professor Wade Ellison showed it in his presentation in different graphs. Without educating the society, without breaking the stereotypes and misconceptions, we won't be able to deploy nuclear energy in Latvia. Austria built a nuclear power plant but didn't launch it because society was mongered against to stand against the nuclear energy, and society and public requested it never to be commissioned. Also, the same applies to Visagina nuclear power plant in Lithuania, but times change, Visvaldis. Yes, times change, and Austria has not still had a courage to reinstate its nuclear course. Yes, but it was during the peaceful times, and now it's a wartime, and it's a different time. Yes, also during the war, especially during the war, we need to educate the society. We have to start with children, with school children, with pupils, with students in high schools, and then move on. Okay, but let us agree. We publish this conference on Delphi. It is an internet portal, news portal, and everybody who's looking for facts can have a look at that. Organizers will also publish everything on YouTube, but Visvaldis, you will go to visit schools in Liepāja, your colleagues will visit schools in other places in Latvia, and we will take care of information raising. Thank you, Visvaldis. We know that the Riga Technical University is...
Izstrādājot, un vēl viens neparasts materiāls, un tur es aicinu jūsu kolēģi Andreju Krašņikovu kungu.
Excellent.
Andrej, jūs kā doktors varēsiet mums
izstāstīt. Andrej, it's your turn, so you will be telling us a secret on a new type of concrete that will serve new cosmic technologies for disposing of nuclear waste. So it's a different kind of concrete. What is it? How is it different? Please show us the formula. Thank you, dear listeners. I would like to inform you on new materials which are linked to nuclear energy. So just a few words on this conference. So this is one of the first steps directed at educating and interesting about the Latvian society on what kind of energy do we use. And unfortunately, the events in the world have led to the situation where we're trying to renew our information. And scientists have to be given the green light in this case because they're not agitating for a cause, they just give knowledge. And the society without knowledge can have very faulty decisions which might have a high cost in the future. So in this conference, we want to evaluate and take a look at what is nuclear energy as a source of energy. So in society, there is a prevailing thought that it is different, it is something dangerous. So there have been only 3 malfunctions in the history of nuclear reactors, and that led only to 15% people supporting nuclear in the world. But of course, if you have such a huge amount of energy concentrated in one spot, it is a bomb. That means you have to work very professionally and consequently and carefully in order to avoid mistakes. If we make small reactors, we lower this risk created with the use of this source of energy.
I'd
like to talk about a project that is purposefully and unpurposefully related to the Riga Technical University, and we are specialists in this type of concrete, because the project actually arrived from our northern neighbors in Estonia. And it's clear why. It's because they are many steps ahead of us in the construction of low power nuclear reactors. They already have projects for this, and they are sure that this project can be made into a reality. And I'm sure that in time, Latvian society will support such a project. So I will show you why. Next slide, please. Oh, I have it myself. So people involved here are scientists from University of Tartu, the Riga Technical University, the Lithuanian Energy Institute, which is directly linked to Ignalina, and the Arctic University of Norway. So the base of the project is concretes which have new ingredients. First of all, they use ash from Estonia, which is accumulated by burning oil shale in Estonia. That happened for a long time. And secondly, using technologies that used fiber concretes, which can screen or protect from neutron rays. If we take a look at this, the question is quite broad. So what type of radioactive waste is there?
And
how does the International Energy Agency advise you deal with such waste? Should you bury it? Should you treat it chemically? Should you recycle it? So in this graph from the International Energy Agency, we have a comparison of types of radioactive waste. So the first type, the least dangerous one, is the exempt waste, which actually do not exist in some countries. There are no regulations that exist that regulate the disposal of exempt waste. So next is next type of waste, which is linked to
pussadalīšanas izotopu.
Linked to a short limited time of use of radionuclides. Usually they arrive from the medicinal field and medicinal appliances. So next we have a very low-level waste, which has 4 different gradations. So they're in the very low-level waste, which are linked to just a small amount of waste. It's written on the slide. I can't talk about each of them in detail now. So now we have low-level waste, then we have intermediate level waste, and finally high-level waste. So we will be talking about all of the types of radioactive waste, and not only radioactive waste, chemical waste as well. So it's a model of the European green recycling model, and this project is within this framework. So this is the traditional way that radioactive waste is discovered, treated. And again, I won't be talking about each point individually. So you collect them, sort them, chemical adjustments are made, etc., etc. And at the end, they are buried. And one of the main types how this burial takes place is cementation. So how you fix this waste in vessels. So, and how do you use concrete in these vessels? So here's a picture from Ignalina, nuclear reactor. I took it off the internet, these pictures. So in Ignalina nuclear plant, there will be intermediate and low radioactivity waste depository. On the left, we see radioactive pieces of material from the reactor, and then they're cemented like in the picture there, and then they're put in different types of containers. So here we have a picture from the Lithuanian Energy Institute. So different types of vessels or casks for radioactive waste. So it's actually used or disposed. Radioactive fuel is actually stored there. So different models, different widths of the walls. So, and the ones that are used here are, all of them have concrete in them. I was quite surprised that the Lithuanian Energy Institution provided us with the regulations, and the regulations were as follows: that concrete has to be ordinary, simple. Dear friends, you know, there was a revolution in the concrete industry 10 to 15 years ago, and there completely different materials were created that your average inhabitant of Riga wouldn't really know about. So there are composite materials created out of concrete. So here we have classification of different types of concretes in different places. So conventional concrete, it's used here in Riga. So all of Riga has been built on concrete, which is has a strength of 45 megapascal. Then we have high strength concrete that has over 100 megapascals. And then we have high performance concrete, 150 and upwards, ultra high performance, 160 and upwards. And our students at Riga Technical University actually have created 500 megapascal strong concrete, which is twice as strong as steel. And how do you achieve that? Well, it is very dense. It's not even concrete anymore. It's almost like glass. And without a doubt, radioactive waste has two problems. First of all, radiation, and the second problem, leaching, right? So radioactive isotopes, for example, in 50 years, 60 years, migrate outside of the concrete. So if you create a concrete that is a barrier, we cannot await any leaching. So that's the object of our study, and that is what we want to advise you to use. As on the slide, you can see the main requirements for concrete are density. Well, the higher the better. We put lead pieces in it. Something from the Liepāja metal processing plant. And of course, something else that is bad is fragility. And if there's all of these deposit materials are added in the vessels, and after a time, groundwaters will make it appear in, I don't know, in Jūrmala on the beach, and if there's all of a sudden there's radiation on the beach, well, that is something that would be absolutely unacceptable. So the characteristics of concrete that have been achieved now in comparison with the concrete that was used for burying radioactive waste, as now the characteristics or properties are much higher, and we have to use modern materials, different materials. We do not need fragility. We will not strive for density. We will have this screening capacity or shielding capacity. So what I want to talk about is fiber concrete, concrete fiber. In Latvia, it's quite a developed market. We are a knowledgeable country in this field. We have actually outperformed American, Scandinavian manufacturers with our knowledge and our specialists from the Riga Technical University, and we know how to use it. So what is fiber concrete? So when you add little fibers to the concrete, it doesn't allow for micro cracks to appear in the concrete. So what are these micro cracks? So concrete is basically like a rock sponge, and through the sponge, of course, you get humidity passing through it. And if you close the gaps, you don't get the humidity, you don't get the water. So here we see different fibers used: glass fibers, poly boron, we have polypropylene boron, and different other fibers. And here we have some knowledge that arrived to us from Tartu with a specialist from Ukraine. They have tried to get basalt boron fibers. So they have a publication here. And when basalt fibers were used, we do not have such appliances. Definitely, the Valmiera plant will not be too happy about that. So, but the people in Tartu got these types of appliances, and they achieved great results. And boron-10 is an isotope that catches warmth neutrons, heat neutrons. And if you use such fiber concretes with such fibers, with such high performance concrete, with the material the ash I mentioned from Estonia, it will not allow the leaking of radioactive material anywhere. It can suffer, and it can leave the container in 60, 70 years, etc., etc. So we're on the right track. Here are the experiments that were already performed. We see how they were checked with radioactive radiation. And now just a few words on the Estonian oil shale ash. In Estonia, oil shale has been burned for hundreds of years, and it's not used too much now, because 1 ton of oil shale burned gives us half a ton of ash. So it's literally mountains of ash. And Estonians are interested if we can use them in a positive way. And maybe if it's a material you could use in the building of new nuclear reactors. And we are thriving to create new materials. So the conclusions are we will have new innovative fiber concretes that will shield from neutrons. And lastly, it will have such radionuclides that that will prevent leaching of hazardous materials as well. So, for example, maybe you might just imagine you might have this concrete vessel heating your home. Maybe it can't even explode. So I'm calling the Latvian society to consider the thought that everything changes over time. So maybe it is worthwhile to think that we will be a nation that will be one of the most developed. We will be the ones to use the most innovative technologies. So, for example, we'll start producing robots, we'll start creating new computers. Well, maybe not computers, but either way, we will start manufacturing a lot of things. And I'm waiting for that moment. I want to see it. Thank you.
Yes, es arī gribu piedzīvot to momentu.
Thank you for the presentation. I'm also looking forward to this moment. In fact, all those innovative materials are definitely among the leaders in our export capacity. Well, this is also like a co-funding factor. It's perfect since a fresh breath in our industry is given by the science, and we have so many innovations. Well, it means that our future will be bright. The next speaker will be from US. She will not be from Estonia, she will be from US, and US is also a country that knows quite a great deal about science. Mr. Māris.
Hello.
Hello.
Can you hear me?
Yes, we absolutely hear you.
Can you hear me?
Yes, we do. And welcome. And sorry for being so early for you. But still, we had already some interesting inserts and inputs. And now we very much like to talk this how the capacity and capability of the grid should be developed or reinstalled or redeveloped, or what should we do with this? You've been working on this issue for many years as a chemistry professor and scientist, and there are several books I should suggest. We will publish them in the background as well, so many people would like to read the books as well. But well, anyway, let's put it a little bit shorter today. We'd like to hear you from what do you think could be these things we shouldn't neglect before we do our political or technical decisions, please.
I want to be sure you can hear me, literally hear me. Can you hear me?
Yes,
okay,
we
good.
do, but
good.
Please, could you also share so we can double check if the share is working?
Oh, I have the screen up there. I think
all right, there is.
Okay. So this is the conference we're all at, so I don't think that's a surprise to anybody. Yes. And I'm trying to move to the next slide. The role of nuclear energy on the grid is what I'm going to be talking about today. I'm not really going to be talking about nuclear per se, though I've worked in that field a lot and I have books on it. It's going to be about the grid because I've been studying the grid for about 12 years, and I had to write a book. It's so complicated sometimes that anyway. So let's talk about what we want before we talk about what's going on. We want a strong grid. And what is the definition of a strong grid, in my opinion? A strong grid is a reliable grid. I can't emphasize that enough, because as one of my friends, Robert Bryce, says, if there's not a reliable grid, people will do what they have to make it reliable. So if you think, oh, we want it to be relatively inexpensive, well, if it isn't reliable, the rich people will have generators at home and the poor people won't. So what I'm trying to say is we want reliable electricity, and next to that, we want relatively inexpensive electricity so everyone can use it, and electricity made with low levels of pollution. But reliability is key. Now, what makes it, what makes what makes a grid messed up? What messes up a grid and makes it unreliable? What makes it unreliable is that it has over-reliance on renewables. Renewables start and stop on their own schedule. Nobody commands the wind. Nobody commands the sun. Nobody commands the clouds. Now, I gave a talk to some engineering students actually yesterday, and I made a point of showing the grid operator's room, the room where there are people watching the weather. There are people watching the grid. There are people watching the frequency. This is not a trivial thing that that you can't order a renewable plant online. Well, of course, we back up the renewable plants, and in general, we back them up with natural gas. Natural gas is delivered just in time through pipelines. Unlike material which is stored on site, which is coal and nuclear and oil, natural gas is delivered just in time by pipelines. And in most areas of the world, I certainly haven't done a huge study of all areas, but in most areas of the world, homes that heat with natural gas have the priority on the gas that's in the pipelines. So if there's a power plant that needs natural gas to make power, but it's a real cold snap and a lot of homes need natural gas, that power plant may not be able to get natural gas. We have seen this in Texas. That was a kind of a wake up for everybody. When I first wrote about it, it was about a near miss in New England. And when I wrote about it, and it was really a close one, in my opinion, there were people who said, well, you're exaggerating. I said, I don't think I am. You're alarmist. I don't think I am. Well, ever since Texas, no one's been saying that. It was the same sequence in Texas as was happening in New England. And the third thing we have as a problem is overdependence on the neighbors. Now, in New England, the problem is overdependence on Canada, which has a lot of hydropower just north of us. I mean, if I go straight north, I hit Quebec. And I live in Vermont. And if I go straight north, I hit Quebec, the Quebec province, and they have a lot of hydro. So we depend on it, but we don't get it in cold weather because they need it. When the chips are down, a power company will take care of their own area first. They will not be exporting power. And there's a lot in my book about how I had noticed that Quebec didn't send us enough, about half as much power in a cold snap. And when I really began to see what they had promised to send us, it was half as much as they usually send us, because sometimes they need it. So let's go, instead of all this depressing stuff, let's talk about 3 ways that nuclear energy supports a grid. Baseload power, over a year of fuel stored on site, and traditional cost support for grid operations. So these are 3 ways that a nuclear plant supports your grid. So let's go to baseload power first. If you are talking to someone who is saying renewables can do it all, they will tell you that baseload is your grandfather's grid. Nobody needs it anymore. All we need is flexible backup, which is usually natural gas, because that's what's called a fast-acting resource. You can turn it on quickly. And that's all we need. Baseload's old. Baseload's so last century. No, it isn't. This is a picture I have of the fundamental issue for all grids. And this is, I took this picture from our ISO New England website, and it's from 2016 because they revised the website, and I don't think the newer pictures are as pretty. But don't worry, I have new pictures from a different website pretty soon. So what do we have here? We have that at 0 hours at midnight, there's only 11 gigawatts of demand on the grid. And at 3 in the morning, there's only 10 gigawatts. But then at 6 in the morning, oh boy, people are turning on, they're getting up, they're turning on their lights, the equipment in factories is beginning to hum with a, and so forth. And then somewhere around 11 at night, it's falling off very rapidly. So you see that there's a variable demand on the grid over a course of a day. Now, one of the things I did with the engineering students, and I won't take the time to play with it here, but I'll say, so anybody ever read the book, How to Lie with Statistics? Very interesting little book. At any rate, what is now ISO New England is not trying to lie here. They're just trying to save space. But what is the intrinsic lie in this diagram? It doesn't go down to zero. It doesn't go down to zero. The fact is that 10 gigawatts is required all the time on the grid. It's required all the time. And so this business of going up to 16 during part of the day, it looks like, oh, we've got a variable grid here, but we have that base load, which is down there at the 10 gigawatt level. So the next slides are going to be 2 slides about New York State power. And what happened here is that in general, there is this idea, oh my goodness, there's something in the chat. Should I be, oh, okay, I don't have to worry about it. Sorry. I'm going to ignore the chat now. Sorry, I didn't mean to do this. This slide was put together by a friend of mine, Isaru Saruro, because the grid operator will not show you a slide showing base load. They just don't do that, as I showed you in the earlier picture. But he put together the electricity for the New York City zone for a full year, January 1, 21 to December 21. Okay, and New York City uses 5 gigawatts when it's not using much power, and almost 9 gigawatts when it's using a lot of power in the summer air conditioning season. So here's a jagged view of it, but you do notice that he takes the picture down to 0, so you can see that basically around 4 to 5, between 3 and 4 gigawatts are in use all the time. That's the base load. And if you're trying to build that base load out of solar, you got a problem at night. If you're trying to build it out of wind, you got a problem. So you're always backing up with natural gas in that situation. There was a beautiful little clip that's been around on some of our nuclear sites of Robert F. Kennedy Jr. saying, every solar plant is a gas plant. He was speaking to a bunch of people who were putting a gas audience at that point. He wouldn't have done that if he'd been speaking to an environmental audience, of course. Okay, no cynicism, Meredith. Okay, the next thing I wanted to show you is, you might say, well, that's lovely, Meredith. You're showing a city, you're showing an air conditioning load. Give me a break. What about the whole thing? Now, New York State is a very varied place. Upstate is very rural. Upstate is apple country, it's farming country. New York City, of course, wow, it is not rural. Everyone would agree it's not rural. So what my friend Isiro Simaro did was he went to each of the zones in New York State, and I don't. The capital zone is Albany. The Genesee zone is upstate places like Rochester and Syracuse. Central is more rural. Hudson Valley is more rural, and of course here's New York City, the big giant. Well, what he did was he divided the electricity use into 24-hour demand, 365 demand, and variable demand. This is demand. This isn't anything to do with how it's supplied. And look at this. Every place is between 55 and 69% 24/7 demand. That is what we call baseload. And that is what your nuclear plant can provide you with. So when anybody says we don't need nuclear because we don't need baseload, just think about this. It took him time to put this together from the raw data. He got the data from the independent system operator, but this independent system operator isn't going to put this out there. Okay, so let me see if I can go on to the next slide. Who knows? Yes, okay. One of the things I consider very important in terms of reliability is fuel stored on site. So here's a picture. This is my area a couple years ago during the near-miss cold snap. And it shows, well, you know, it gets hard to get your car out. And it was also, the weather was pushing. I live in Vermont, and if I want to buy a plant, I'm supposed to buy a plant that's hardy up to minus 30 degrees, okay? 30 degrees Fahrenheit. So this is a cold snap where we were getting down to minus 20 degrees like day after day. And I wrote this for our local paper where I said on January 6th, the temperature was minus 8 Fahrenheit, and it was minus 15 the next morning. So that's the excitement. What I did was our grid operator was very well aware that under these circumstances, our homes are using a great deal of natural gas, and the power plants can't get natural gas. So our grid operator made a winter reliability program, which meant that the grid operator partially supported, partially paid for oil to be stored on site at dual fuel plants. Now, oil kept the power grid running during this cold snap. During an ordinary time, we use almost no oil on our New England grid. We have natural gas, and we have solar, and we have nuclear, and we have, and so forth. So we don't use very much oil. During the cold snap, the grid was running on 30% oil because oil is stored on site and you can get it. Now, in all honesty, it was pretty touch and go anyway, because so many plants depend on natural gas. And so the grid operator stored oil on site and this is from their, it's called the Winter Operation Report from that time period. It's from our grid operator's report. And it gave an example of a specific station. This station could store 9 days of oil on site. At the beginning of December, which was before the cold snap really began, it had almost 8 days of oil on site. And then the cold snap really kicked in. And as you can see near the end, it had 1 day of oil on site. So this is what I'm trying to say. When your grid is running 30% oil and you got 1 day of oil on site, this is what I call a near miss. And I'm sorry to say, a lot of my book is about the management of the grid. I'm sorry to say that our grid operator shut this program down as being too nice to oil. The RTO grid, FERC, the Federal Energy Research Commission, the federal agency, shut this program down, telling our grid operator that the grid operator was being too sweet to oil and it has to be fuel neutral. Well, anyway, I wrote a book about this. So finally, let's get away from the idiocy of the grid operators and talk about nuclear support for grid operations. And I just want to say that nuclear is a huge supporter of grid operations. Many renewables are inverter-based in base. That is, they make DC energy, and then there's an inverter that turns it into AC energy, which is what we all use. And nuclear is not inverter based. Now, if you begin asking me very complex questions about this, I will have to step away because I'm not an electrical engineer. So I don't want to get too deep into this. But basically, nuclear can supply what inverters cannot supply, which is inertia. That is, it's got the spinning thing and it keeps going. You know, it's not on and off. An inverter is an on-off switch. And it can support voltage and frequency because of that inertia. And so let me go back to this for a moment here. Nuclear can support voltage and frequency. We had an experience recently where we had some wind energy coming onto our grid, and the developer was in some sense cutting corners. He in order to get tax credits, he had to get it on by a certain day, so he asked to put it on the grid. And the grid operator agreed, but said, you know, we'll be curtailing you a lot because you're inverter based and you haven't put on synchronous condensers. So about a year or so later, he built synchronous condensers, which are basically spinning machines that kind of mimic a nuclear plant or an oil-fired plant, by providing inertia to the grid and supporting voltage and frequency. So nuclear energy is good for the grid. And that's about it. I wanted to try to make up some time. I don't know if I did, but maybe I talked at a mile a minute. I don't know. But at any rate, I just want to say that I'm always happy to hear from you. Here's my book about the grid. And my name is Meredith Angwin, and if you know Meredith Angwin, you can get hold of me all kinds of ways because I'm at Meredith Angwin on Twitter and Meredith Angwin at Gmail and meredithangwin.com and at my website. So anyway, that's basically it, and I will now stop sharing my screen.
Well, anyway, thank you, actually, and we will be reading your books online or maybe even buying and getting them, and grid is important in all this area. And by the way, we are in a historical even weeks because just recently the interchange and connections was fully connected with Europe. We could celebrate now. We are fully connected, and actually it happened just recently. Up until now it was like half connected with Europe, and for us it's very, very important. Now, Kalev, today I think we learned, all of us, that we should reconsider what we know and what we fear of, and probably start a kind of new era of what? Explaining to each other. There was a lot of facts, so we are much stronger today, each and every one. We can rely on science-based facts, but should we now address whom? There were many people in the chat room talking, okay, that's nice, but come on, we will be not able to explain it easily to the public. So they even said we should restart learning physics from almost experience of the collapse of USSR. That was a kind of a problem that people don't accept because they are feared, because they don't have enough knowledge. So now we have knowledge. What should we do?
Yes, indeed, learning is very, very important. My companies, we are investing also heavily into stipends. And actually for the society at large, as well, as we have still 1.3 million population in Estonia, 1.9 million population in Latvia, learning and getting educated, being indeed knowledgeable, this makes us strong. And if you are stupid, uneducated, we are weak. And weak will be conquered. We know that. So that is why we, and also in energy questions, what Meredith explained, what others have explained, the biggest challenge when it comes to nuclear energy is really to get educated, to get smart, to utilize that energy, which is the most science-based energy, most knowledge-intense energy, but also the highest value creating energy form, value added creating energy form, to learn it. And that is the challenge for our societies. That is the challenge for our organizations. Are we able to communicate, reach out and talk to the whole of society? In Estonia, we have had communication or explaining nuclear energy in 60 public schools out of 200. Our aim is to go achieve every public school in Estonia, and we have people working on that. We're regularly on different media outlets in Estonia, and this is the intensity and the challenge to educate. And if you do that consistently, I showed we have results. So that is also the challenge in Latvia, the primary challenge to educate your society, your people, and take responsibility.
We will, absolutely. And can I ask for you first, and then Andri for you? Sorry, switching to Latvian. Ja mēs stāvam šeit šodien.
So if we are standing here today, it is Wednesday today. So we are standing here in front of the audience. And yesterday, it was a day when the government decided to include solar and wind energy as strategic reserves. So we have understood that probably there will be another iron curtain soon to be falling. And a new law has been drafted. Soon it will be submitted to the Cabinet of Ministers and Parliament for approval. So the new law includes wind energy and solar energy as alternative sources for reserve power. Shouldn't we include also nuclear power in this list? What do you think? Well, in this conference, we talked a lot about wind and solar energy as, well, let's say, unstable and relatively unreliable sources of energy. It's not possible to meet the whole demand of power consumption merely by solar and wind energy. As Meredith showed in her presentation, nuclear energy is supporting inertia. Inertia is necessary to resume power supply after some breakdowns. In larger power plants, inertia is needed to reinstate frequency after breakdown or idle time. Wind energy or solar energy cannot provide that. That's one thing. Another thing, renewables are unstable and they are unpredictable. The sun is not shining all the time, wind is not blowing all the time, and we need to look for other sources of energy to use it as an alternative reserve. That's the reason why European Union delegated taxonomy acts stipulate for transit from renewables to gas and nuclear energy. So we will also have to do this transfer, this transit. There's a question to Andris Šternbergs. You are a physicist, so you have heard many things, I guess, and you have suffered quite a lot from the uneducated, well, let's say uneducated opinions of people. Well, you know all those protesters who say, stop telling us that nuclear energy is green. Yes, it is Brussels that is simply trying to push nuclear energy on us. We are going to go out on streets and we are going to protest the nuclear energy, nuclear power. And that's what our granddad did during the hippie era, and that's what we will do. What do you think about this critical attitude by people? Because, well, you as a physicist must have different outlook on people who are really categorical about nuclear energy. Yes, everything a part of nuclear energy. Well, yes, nuclear energy is relatively new. At first, it was associated to such bad things as atomic bombs or nuclear bombs on Japan, on Hiroshima, Nagasaki. Then nuclear issues were related to Chernobyl catastrophe, also to the disaster in Fukushima. And people simply find it difficult to differentiate the benefits of the nuclear energy from the risk it can cause. Well, we have heard about Germany phasing out nuclear energy. The same applies to Lithuania, that at first decided to build a nuclear power plant and then held a popular vote to vote against actually launching it. So I am really jealous of Estonia, that is on the way of launching its first nuclear power plant. At least there's political agreement on that. Well, as to the knowledge in physics, well, physics is just one of the natural sciences. And school children should be engaged, should be made interested in the natural sciences, and education should be started from early age. As to the renewables used as alternative reserve or strategic reserve, well, probably is the 15%, as it's now stipulated in law, is not enough, and we would have to think of ways how to find a balance, between green energies, energy supply, energy security, meeting the aims in stipulated or defined in the European Green Agenda. But probably our marketing slogan for nuclear energy could be that nuclear energy is green and we should use it.
Around the schools and explaining the things. So now I ask Andris and you and everyone to join this, but to do it in Latvia, in their own schools, and to explain it. Dāmas un kungi, te bija ļoti daudzi, kas latviešu valodā, of course, go to latviešu schools and do it. Vienkārši kolēģi, te tik daudzi bija komentāros ar savām domām, kāpēc mums ir tā.
Dear colleagues, there were so many people who voiced their guesses, or who wrote their guesses on why the situation in Latvia is the way it is, why people have so poor knowledge in physics. Well, I actually studied in 4 different schools, and the quality of physics education was the way it was. It probably could be improved. Think back of how high the quality of physics education was in your school. Probably all the scientists could help the school faculty. Well, it's not always to be done in school environment. We could also do something similar to what is done in AHA Center AHA Science Center in Tartu. We could organize special film screenings in cinemas. Films would be dedicated to different topics of physics. We could go with our education program to schools. Well, schools are definitely what we should target. Yes. Thank you for being so responsive. Thank you for being so willing to act operatively.
Are much stronger, I think, after today. Tad, dāmas un kungi, liels paldies. Tiešām lūdzu neaizmirstiet linku, kas būs YouTube'ā pieejams.
Ladies and gentlemen, thank you very much for participating. Please share the link of this conference. Probably there was somebody who changed his or her mind during the conference, and there's somebody who could definitely benefit from listening to all this information. More than 300 participants joined the conference to listen to everything.
Everyone also around the seas. Yes, thank you. Bye. Paldies.
Hey,
paldies, Andris. Paldies, forši, ka mums izdevās. Dodiet, jā, paldies. Dodiet mikrofonu.
Team of scientists led by Mr. Walterson had built a breather, unlocked the energy within. Enrico Fermi saw everything that could be. We switched the breather on and the neutrons made photons. Clean power forever within our grasp. By splitting atoms, it's come to pass. Tomorrow will be so great. Clean power forever. December 20th, 1951. Our dreams of fission had only just begun. Nuclear now makes 60% of our clean energy, saving 2 million lives just in this last century. Clean power forever within our grasp. By splitting atoms, it's come to pass. Tomorrow will be so great. Clean power forever will be our fate. Clean power forever will be our fate. Clean power forever.